Welcome, everyone. Thank you for being here. To all the SQL a Python needs to know, we're going to be talking a bit about DuckDB. We'll talk a bit about MotherDuck as well. Jacob and I both work at a company called MotherDuck. So the question is, what do you call someone who works at MotherDuck? Baby Duck. Good guess. It's Mother Ducker. That is the correct official title. So we are very serious people, which means ask us questions all the time. One of us at all times is going to be walking around helping out, flag them down, flag us down. This is all about, we want you to get as much out of this as possible, which means we want you hands on the keyboard doing it. And so if there's any point where you get stuck, there's a lot of ways for you to catch back up later, but please stop us. We really want to make sure that you get to participate. So while we're saying hi, giving a little spiel, we recommend going to this link and following the setup instructions so that way when we're done saying hi, you'll be all set, ready to write some SQL. Sound good? Sweet, thank you for the nods. All right. Why don't we do a handheld mic? Yeah. So, want to say hi?
Yes, I'll say hi. Hi, everybody. I'm Jacob. I work with Alex here at MotherDuck. We are, building a awesome database on top of DuckDB. I work here in DevRel, so I get to do marketing, but I don't get to say that it's marketing, which is very fun. And Alex here can introduce himself.
Sure. Well, howdy, I'm Alex. I'm a customer software engineer, which means I talk to people a lot and help them with finding bugs. Spend a lot of time in Datadog. But I'm a recovering data scientist, so love the science side as well. So my background is industrial and systems engineering, but then I got into this programming thing at an internship where they handed me a spreadsheet and said, hey, this uses VBA. The last intern did it. We don't know what it is. You do it. And then I got hooked, and I've loved it ever since. So my next couple internships later, I picked up SQL, and I literally bought the book SQL for Dummies, and I read the whole thing cover to cover, and then I went back to the chapter on joins, and I read it 3 more times because it was really hard. So we're going to short circuit that today. You're not going to have to read it 4 times. But that was 12 years ago. Been using SQL for part of my day job ever since. Couple years worth of that was 100% SQL all the time. It's been really a key part of my career to be able to learn that, and want to share it today. So feel free, give me your best shot and see if you can stump me. Let's do it. All right. So we did want to talk a little bit about why SQL, why learn it in 2025, and a little bit about what we're going to be talking about today. So the flow today, we're going to spend 2 hours doing some SQL together. We're going to start with some of the basic syntax, move into how to combine data from different data sets, and that's going to be all in SQL. After that, we're going to switch over to some Marimo notebooks, and we're going to mix and match SQL and Python. So that way you don't have to switch over to SQL wholesale. You can sprinkle it in whenever it helps get your job done. And then we're going to also talk about how to then take it to the cloud in the last hour, as well as how to use AI with it. Turns out AI is very good at writing SQL because SQL's been around forever. About 50 years now, which means there's a lot of training data on the internet, and it is very well trained. So we're gonna learn how to take advantage of that. And I wanted to start off a little bit about why learn SQL. You guys are already here. Don't need to pitch you too hard. So think of this as information that you can use to talk to your team when you want to share what you learned at SciPy. So why SQL? Because SQL's been around for 50 years, and there's this thing called the Lindy effect, which says the best predictor of how long something will be around is how long it's already been around, and use that. So SQL will probably be around another 50 years, is what that would estimate. The longer it's around, the longer it's guaranteed to stay, because it's everywhere. Some databases still use the code from 50 years ago, which is pretty wild. IBM DB2 has not changed a lot. Oracle, similarly. Today we're going to be using the friendliest database out there. It's called DuckDB. It is an in-process database designed for analytics. So in-process databases, the most popular one, actually the most popular database in the world is SQLite. SQLite is everywhere. It's on aircraft. It's in every browser, every phone, all operating systems, all computer hardwares. It comes in the Python standard library. It's everywhere. So if you ever need SQL, SQLite is wherever you are. If you're using Python, I can guarantee it. And DuckDB is 1 pip install away. It is a fully self-contained package with no dependencies. It's precompiled for basically every platform we can think of, and it's 20 seconds or so, and then you've got it. So why would you use DuckDB over SQLite? DuckDB is designed for analytics. So if you have 1 million rows of data, you got 1 billion rows of data, You got a terabyte of data, DuckDB will chew through it happily, and SQLite will be less happy. DuckDB is somewhere around 100 times faster than SQLite for these types of workloads. It's also a lot friendlier and simpler. So we've taken the SQL language and simplified it as much as possible and actually made it more Pythonic in a lot of ways. So trailing commas are allowed. They won't yell at you for them. Like, wow, this is great. 50-year-old language can dance. So we're going to spoil you today. You're about to use the greatest SQL dialect there is, and all the rest are worse. So sorry about that. So we're gonna ruin you there, but hopefully you'll enjoy it along the way. So that's a little bit about why SQL, why DuckDB. At MotherDuck, we're building the cloud data warehouse on top. So if you wanted to have this be something, a shared resource for all of your company, for everyone on your team, that's where MotherDuck comes in. We do have a permanent free tier. So we're going to try that out in the last section. You guys will all get a free trial. All right, so wanted to do a show of hands. How many folks have written a line of SQL before? Oh, sweet. This is going to be great. Awesome. How many folks have used pandas in the past? Okay. Polars? Anyone polars? Okay, a couple polars. How many people have used IBIS before? Okay, we're learning something new today. Cool. We're going to do a little bit of everything. So let's see. So how many folks have done like joins and aggregates in pandas or polars? Some of the complex stuff. Sweet. Awesome. And how many folks are recovering spreadsheet fans like me, Excel power users? All right, sweet. Fantastic. Great to have you there as well. So we'll use a lot of different analogies as we go into SQL. It will be similar to things you've seen before based on your show of hands. So it's 50 years old. There's nothing truly new under the sun. So we'll use a lot of analogies and we'll get into it. So who is still setting things up and getting into our notebook IDE? All right. Well, let's take 2 minutes. We'll go around, and both of us will help you guys get going, and then we will jump in. All right. So raise your hand again if you need to know.
We're probably going to be fighting like corporate stuff.
Okay.
Okay. But I do have admins on.
Okay, so I did not put a link in. What are you seeing?
I'm just looking for a download for it. I put in Python package, but so you should just did just that link. Okay, then it should have it there. So it should have it.
There it is.
All right, where do we want to put it?
You're on Mac OS. You can actually install it with that little show command, and that will install it. So if you just run that command at any terminal,
I think so.
So there you go.
All right, now let's try that.
all you need to do is install it. Has to be so yeah, you got step 1 all set. Then step 2 is to pick over and top of file.
Oh, I realized that's probably.
On your way.
Yeah.
Other questions?
Okay, so that's the command line interface. Okay, awesome. Do you want to take a look at the next step, and then if you get stuck,
Yeah,
you know,
sure.
I'll-
Thank you.
All right, I'll show you. Okay, so because you are in the because we can't essentially use a slightly different command, so you can do one thing. You can exit the UI with Control D. Control C. Okay, well, open it. So open up PowerShell.
So that's step 1. Then the other ones are to get our notebook.
Okay, now you /.
All right, question. Yes.
Do I put the CLIs into
Why is it doing this? It's not
Really
and
anywhere.
then which one goes on the back?
DuckDB.exe would be good to have whatever you have.
It's not an outside call. In this case, start underscore UI.
Let's see, do you mind popping open
Close
let's
parentheses.
see if we can do
No space, no space. Close parentheses and then semicolon. So this is basically running as a function instead of from the flag.
Yeah. Yeah. Great.
Great, that's
Okay.
step one. Do you want to go ahead and take a note of
Yes.
Oh, I
You're in.
think I got it.
Okay, great. Then just the command to run is, and you drop that in where you want to?
Yes.
That's perfect. So the way to do it is if you could start a terminal in this folder instead of directly clicking on the app. So just go back to your terminal.
Oh, okay.
And just hit Control V, search that down there over here. I've got. That's all. So there's another command for show UI. So if we go to
That instruction, we need to put that DBUI in a specific folder. So it should go.
this is what we're getting. Yeah, that's working.
Oh, you're in that folder. Oh, I see that.
So since
So
you
now, you should go to run DuckDB.
So the call
Dash
start underscore UI.
Okay, so not now, because it's not in the path. Yeah, I don't see that. It needs to be dot slash.
And it doesn't have any written. You can use Chrome or Google. It just doesn't have.
Just prompt that.
So that should be Should be good. Okay, great.
Alex, can you look at this one? I'm not sure.
So.
Just want to make sure you're right.
That looks right.
Okay, this is where it should be.
Yes, you have the database, you have the notebook. That's great.
Okay, sure. So let's navigate to the folder where you enabled that and then kind of give it permission. Okay. All right. But it's going to be through the finder. So wherever it is installed, you just kind of right click on it, then do open. That should allow us to give permission. And then- Okay, so if you click on the question mark in the top right, it'll tell us where in the site is page. Yeah, so let's go to, we're going to have to go right into this thing. Oh, here we go. Oh, yeah. Now, we should be able to keep that up in the box. So we do the vision recognition. So, Thomas, this is really great software. Just a All right, that should pop open in the browser for you. If you go to Chrome, you should be good. For sure. All right. Questions? Yes. Oh, very good.
Simple binding failed.
There's another alternative. So right in that folder that you're looking, I just take call space.
That's a crazy.
Start underscore
It's just not on your path, so.
It shouldn't.
He's supposed to have a waiting error. Did you install it yet?
There's definitely.
Okay, so we got one more G. Which I meant to put a link on, but it's not. Okay. That's okay. Drop down, there's an installation at the top left.
Is it possible that?
Inside me.
Yeah.
Well, yeah, this version is wherever you land this file, that might be another way. Double check something file. See if I can get it working. Can you holler?
Thank you.
You bet. How's everything? So maybe we go back in time to an older version. I don't see no runs at the There's some Google Code as a fallback option.
Well, that's still the problem.
Well, no, the terminal there is still fucking, it's running the actual terminal on Thursday's sheet, right? So there's no terminal. Correct. The original process is going to skip. Yeah, you're going to be ready for section 3. You're on. Okay. No, that's okay. All right, so I'll flip over to what I'm hoping you guys all see shortly. Show of hands, who is seeing something like this? This is just me making sure you exercise your arms today. All right, thank you. We will be getting going very shortly. All right, well, I'm going to go ahead and jump in and give you guys a tour of our UI, and then we're going to start hitting some SQL. How's the mic? Do I need to step back? Good? All right, thank you. Appreciate that. All right, so quick tour of the UI. This is freely available UI you could take with you and use after this, no problem. We're in the process of making it open source, so we're working on that. On the left-hand panel, you've got your notebooks on the side. We've got, for each section, there's an exercises and then an answer key. So if at any point you want to catch up, or if you want to skip ahead, there's also your answers there as well. On the bottom, we're also going to see our tables once we add some tables, so you'll be able to explore them in that panel as well. We'll look at that shortly. And then this is a notebook interface, but it's a SQL notebook. So there's no Python that we're going to run in the first 2 hours. We're going to jump into a Python notebook after that. But this personally is my absolute favorite environment for writing SQL. So I couldn't not share it with you because it just is so delightful once we get it up and running. I think you're going to love it. Okay, so let's get going. So section 1, we're covering a bit about SQL. So first thing we're going to do, we're going to bring in some data. We'll show you how straightforward it is. We're going to pick out exactly which columns we want to see out of that data, which rows we want to see out of that data, and then we're going to sort it the way we want. It's kind of basic, straightforward table operations. And then the next section will be diving into the weeds. So scroll on down with me here to our attach operation. So this is a syntax that's shared with SQLite. Only have to run it once. This basically says, please create a persistent database for me. So if I close down the UI and go back to it, my data is still there, so I don't have to re-import my data. So if you run this command, you can run it with the arrow here. If you hover over it, it also gives the keyboard shortcuts. Should be just what you're used to in Jupyter. So you can do Command Enter or Control Enter, and this will attach a database for you. You should see it pop up in your bottom left, SQL_training. Once you have that database, let's add some data. So here, we're running a create table statement. So that's the first thing to know about SQL. SQL is not just about pulling data. It's also about building data sets and building a database that can contain your data persistently. So there's three different types of SQL. One is like data definition language. So that's where you're defining what your table structure will be. That's what we're running here with create table. There's other pieces of syntax where you're inserting into that, and then we're going to spend most of our time querying it, which will be our select statement. So this is just the one thing we need to get going is create our table weather, and then we are running a little bit of SQL here. So we're going to create table weather as a select star from read CSV. So what does this syntax really mean here? Select star says I would like to get all columns. So the star here is meaning all columns. And the from is pointing to what's the table I want to pull from. And here we're already going to spoil you with DuckDB. We're not pulling from a real table. We're pulling from a CSV file. And we're pulling from a CSV file in GitHub. You can pull any CSV file in any GitHub repo with this syntax, with DuckDB. Just pull data from all over the internet. You can pull data from any S3 bucket, any Azure Blob Store, any Google Cloud Storage bucket. And it's just built into the syntax. So you can say select star from read CSV, and then this is the path to some Washington weather. Because when in Rome, you look at the weather. So that's what we're doing. What you'll see returned when you run this is a count of how many rows were inserted. So it's a small file, a couple thousand rows, and you should also see it now here in the left-hand panel. So if you expand out SQL training, you won't have quite as many tables because I've run through a few examples already, but you should see this table called weather. So I want you guys to click on that real quick. And this is part of this UI magic that I'm super excited about. This is an automatic profile of your data. This will give you the distributions of all the columns. And so if you click on each one, it'll actually break it down, and it'll show you, a very interactive summary of the data we're looking at. So we can see this is data from 2023 across the whole year, and we had the most data points in January. We can see the temperature fluctuations here, so we have a nice distribution of kind of the temperature range. This is in Fahrenheit, so pretty chilly. I'm from Phoenix. 57 is like the dead of winter for me, so like I got some adjusting to do. But that's kind of the first nice thing. When you're exploring your data, we have a really quick and easy way where you didn't have to write any SQL to get all this profiling information. It's just easily available on all of your tables. Frequently, when I worked at Intel, we had more tables than we knew what to do with. And half the problem was just understanding what was in the table, understanding where the data came from, the data quality. There's a lot of exploration that goes on. And this UI is purpose-built for exploration. So you should see a lot of those features. All right, everyone have a table. Weather. You guys have seen it. Seen the distributions. Awesome. So let's learn a little bit about SQL itself. So what we want you to do actually is do a quick little exercise. Get you guys hands on keyboard. So exercise 1.01 says recreate the table called weather by selecting all columns in the file. So this recreate here is, the hint is in the comment above. There are ways to override existing tables. You're going to want to do create something like this. And there's also a link to the duckdb.org docs. So have a quick run. I'm going to have you change one thing here, actually, in this dropdown. Flip this back to default for me. We're going to use Instant SQL in our next example. And then as you run that command, give me a thumbs up so I can get a sense as folks are wrapping up. Do you have a second for a question?
Oh, yeah.
In the maroon shade.
Yeah, yeah.
Did you say you wanted this to change?
Just try and recreate it.
Okay. Maybe.
Actually, so I got DuckDB running, but I don't have the notebooks.
So that means that we've got to drop this UI.db file.
Okay, so same place that the EXE is.
The exe can live anywhere in the machine. You're going to want to use the Windows path here.
Okay, so I've got that.
So first, let's close the UI because we actually need to. So before you do that, do you mind closing the UI just because we're going to be trying to modify the document?
Okay.
I have it downloaded. Because I have the.
So the reason is that it's not the right path. So it doesn't have access to that. So just go to,
Great, so then let's close the door and let's run that UI.sheet a little bit.
all we're doing is creating a database. So we can just use like actual paths. So we can do
It's got to be in, I would just copy and paste the percentage of profile percent. Drop it in.
Perfect, thank you.
You'll find that there's a large path file there. Clear out whatever's in that folder.
Okay. Perfect, thank you.
Things in there.
I usually, so I think I moved it to the correct.
Okay, and just do C, yeah, just do C to JSON.
Change that slide, just download that into the program space files, like how many hours it'll So here's a trick. Go back to that, there's an alternate place. Go back to the, hey, it's right on the database. So let's just type call space, start underscore UI. Missed the T there.
I sure did.
You're gonna want to hit the semicolon and so we can cancel it out.
Thank you.
So call start underscore UI.
So what's happening is
Let's go to the folder where
So you go back to that DuckDB. I know. So it's not really hold this down. We're just doing this.
Oh, okay. I'm sorry.
Please hold tab.
That's right.
Okay. So now you should know what basically what's happening here is my turn on when this player is asleep, when this tab is asleep, and then you go back to it and it wakes up. Now this should maybe fix it. Well, they don't want to bill you. I mean, it's obviously so he put that in. And so now let's go back. And refresh it.
So it's that one out.
Okay, well, this is we're off-roading a little bit here. So,
Good to go.
and sort of.
do dot slash DuckDB instead. So let's just not underneath. So let's try dot slash DuckDB.exe.
So we don't really need user code editor, but we're just going to have some tricks so that so go ahead and install it.
So you can just no problem. Oh no. Oh yes, that's where you No, you were right, just see.
Yeah, that's it, so that's what I was trying to do.
I see, but let's just do, yeah, dot slash DuckDB.exe. Space dash U. You might need to not have a space. Okay, let's just do the dot slash. How does it just, for some reason? Okay, so let's not just move forward. Granted, so we're going to go in Explorer. Sorry. Is it, no, no. So right click on it.
Hopefully it should say live preview and it should all work. Success.
Yeah, because I don't think I can do it directly from my home directory.
So I think this is.
Okay, so let's see, we can just have you follow along.
Yeah,
Google
I'll just
Lab.
follow, yeah.
But if you go to the motherduck.com/SciPy, there's a Google Colab link, so that.
Okay, let's try it. It's still going to erase that a little bit. It's like timing something. Let me see if it. All right, so
Thank
if
you.
there's any slight difference,
Yeah, no worries,
That's our
thank you.
private agenda.
same behavior.
Questions?
Exact same environment.
All right, let's do some SQL. Let's do it. Thank you for your patience, everyone.
Installing local software is great, but once you have it installed, you have it forever, and it is amazing to have in your tool belt. So we'll do the cloud stuff in section 3. So we have created a table. Now, how do we understand what's inside of it? I guess first let's review the exercise. So we wanted to recreate a table. If you tried running the same create table statement again, SQL will tell you something like, hey, that table already exists. What are you trying to do here? There's one small trick. Just try this one trick. Click Beatty title and everything to make that work. We have the create or replace syntax. This is another one where the old SQL way, if you guys are familiar, you'd have to drop the table and then create it. You could do create if exists is another friendly option where you won't recreate it. This is actually going to force the recreation to happen and say, hey, the CSV file is updated on the internet, grab a fresh copy. So you create a replace. So we have some data. Here's another friendly SQL feature we can use to kind of understand what's going on. So this is a describe statement. This helps us understand the columns that we have in our table and a couple of column types. What's this varchar business? It stands for variable character. It's a string, and that's all it means. In the dark old days, you used to have to specify how many characters in your varchar. So you'd have a varchar 5 or a varchar 10. When people were miserly with their RAM, now you just call it varchar. We'll give you as long of a string as you could possibly desire. If you do a terabyte, I bet you could. I wouldn't recommend it. But you can max it to your limit as much as you like. We've got doubles. It's a typical floating point there. We've got date types and big int. It's just an integer, but it can be a very large size integer. So it's a 64-bit integer. That's all that means. So what's this other column here? Null, yes. That means that we're allowed to have null values in those columns. What's a null value? It's probably the trickiest thing to learn about SQL, and we'll kind of see it throughout today. A null is a missing value. It's like none in Python. None does not equal none in Python. Similarly, in SQL, null does not equal null. So we got to watch for that when we're trying to match things up. But in general, it's kind of this void of like your data is missing. It has a couple different meanings. We'll see cases where we will deliberately put null somewhere because we want to know if something is missing. It's a useful indicator. So we will see nulls as we go. But that is a quick look at our data. So now let's dive into the SQL we kind of already ran behind the scenes to go ahead and create that table, and we'll just pick it apart a little bit. So here we're looking at our select clause. SQL was designed to be human readable. Now you can argue that after 50 years of evolution that may or may not be true anymore, but it reads a little bit like a sentence, and that's why the order of operations is a little interesting in SQL. So what do you want to do? I want to select these columns from this table. It's kind of like an English sentence. It's a little odd though, because the first thing you usually want to do is figure out what table you want to start with, and then you figure out what columns are in your table. So SQL is a little bit backwards that way. DuckDB is once again going to spoil you. In DuckDB, you can reverse the order, and it'll work just fine. Because that's how our brains work, and we're like, you know what? Start with the table first, and then you can select from that table in that order. So we did want to teach you, this is one of those things where, like I said, the AI comes at the end. We want to teach you the traditional way, and then we'll branch out as we go. But DuckDB has that nice little feature. I want to use this opportunity also to tell you a little bit about the UI feature. That is my favorite thing about our UI and my favorite thing about writing SQL in 2025. And that is this feature called Instant SQL. So right by the play sign dropdown, if you guys could all switch into Instant SQL mode, we can play around with that a little bit. So what is Instant SQL? Instant SQL is sampling your data, it's grabbing just a few thousand rows of it, and it is going to run while you type, because it's fast enough to actually run and execute while you type it. So let's say I just wanted to look at the station and the name. Right? It already ran the SQL while I was typing. So you guys will get to use that throughout today, where it's a very, very quick way to iterate through writing your SQL statement. It'll also give you handy error messages right below here as soon as you type them. So you don't have to type it out, hit run, wait for a couple seconds and figure out there's a problem. You can stay in your flow state, play around with it, see the errors as you go, and your results will update at the bottom. Now note this is a preview mode, so it says deliberately showing preview results. It won't have all your rows, so if you want to rerun and actually get your full results, just hit the play button, and that will guarantee you to get all your results. So what we were playing with is we were replacing that star by actually telling the database what columns we wanted to grab out of there instead of the star, because the star means everything. Any questions on our select star, first part of our select clause? Sweet.
Do you need the select, Alex?
You know, in DuckDB you don't. In DuckDB, believe it or not, we did before. So first kind of stereotypical SQL statement is select star from my table. We first did a nice DuckDB simplification by moving the select star to the end, so we could go in the mental order of starting with my table, then pick out my columns. But within DuckDB, we also recognize if you don't tell us what columns you want, you probably want all of them, not none of them. So we'll just give them all to you, right? So this is how SQL should be in 2025. Just tell me the table, and I'll give it to you, right? But if you try and run this anywhere else, you will realize how spoiled you are today with our lovely DuckDB. All right. Thank you, Jacob.
Yeah, of course.
Okay. A lot of times, the data we're working with can be fairly large. We don't always want to grab it all. One of the benefits of using SQL, especially in a data science workflow or a science workflow, is that I can save my data to disk and just read only the pieces of it that I want into memory at a time. So instead of pandas, I want to read the whole file in, and you need a lot of RAM to do that. And it's hard to download more RAM, it turns out. So what you can do with DuckDB is you can just pick out just the data that you want to look at off your disk. In this case, we're all in memory, but this is a useful construct in SQL. So previously, we had done our select star to grab all of our columns. To filter on our rows, we're going to use a where clause. So I kind of glossed over it at the beginning, but within SQL, the spacing is arbitrary. I can put as many spaces in between things as I'd like. The key are these keywords, and they're kind of space separated from the things that they're associated with. So from weather, I could space that out as much as I'd like. It's the order of how things are kind of laid out that's important. So after our from statement, we want to include another clause. And we indicate that clause with the keyword where, basically our filtering clause. And then we have an expression. And as we'll see, we can add multiple. But here we're going to say where this particular column, temperature observations, are over 82 degrees. So I only care about the hot days. So I want to only see the rows where the day was warm. So if you click run, you hit Control or Command Enter, you'll see that we have filtered down to only cases where we have warm days. So it's above 82. So that's how we start to filter down our rows and only grab the data that we'd like.
Alex, do you want to talk about other words that people use to refer? Well, let me just
Please.
So I'll just add a couple things that people usually, you may hear, especially when you're working with people who are familiar with SQL. They like to call these things in our where clause predicates. That just means a logical filter on your data. But again, I'll just repeat what Alex was saying, which is they're just repeating. It's just filtering your data set down so we can see a smaller subset of it. So from a syntax perspective, when you hear the word predicates, know that people mean where clause generally. Sometimes they mean joins, which we'll talk about later. Anyways, keep going. I'm sorry.
Anytime. Jump on in. All right. So now if we had our powers combined, we can filter on both columns and rows. So instead of selecting all my columns, maybe what I really wanted to know is just my station, my name, and maybe my temperature. And I can give that a run, and it'll just return just what I was looking for there. I could also be in instant SQL mode, and it would have already run without me having to click run. All right, so we filtered our columns, we filtered our rows. How do we do more complicated filtering? So SQL uses Boolean logic, where you can have a variety of different ways to filter things down. The most common thing is I usually see AND logic, where I want to look at hot days, in this particular station, or hot days in this particular city. In this case, we're using an OR statement here. So this is saying I have two different things I care about. I care about either when there's a lot of rain or if the station is high in elevation. So we can mix and match these criteria. So this is returning 366 rows. Let's see if there's any cases where both of these are true. So I'm switching our OR to an AND. And there's only 2 times where we had rain at a high elevation. So not very common to have rain on the mountaintops. You can also use parentheses to do a lot of really complicated and or logic if you need it. By default, you don't need the parentheses. It's only if you're getting complicated. But again, SQL is kind of space separated, so we just have the expression, space, and space, my next expression. So we didn't need parentheses. We didn't need to call functions. It's all kind of written somewhat like plain English text. All right, a couple other notes here. You also saw we just specified numbers just directly. If you want to specify strings, you want to wrap those in single quotes in SQL. And we got this in this note here. If you want to refer to a column name with spaces, which I'm so sorry if you have to deal with columns with spaces in them, but that happens. You'll want to wrap those in double quotes because SQL cares about spaces. From space table, spaces are syntactically important. So that's why if you have spaces in a column name, you got to wrap them in double quotes so we get to pretend those spaces don't exist.
So
Yes?
You differentiate between double quotes and single quotes?
Yes, that's a great call out. So the question was, do we differentiate between single quotes and double quotes in SQL? And we do. And the answer is even worse than you know. So different databases do it differently. So that's fun. But yes, so the most traditional, the most common is single quotes for strings and double quotes for columns. Other languages use backticks for columns. And there's even some really ugly ways you can do multi-line strings. It gets worse from there. So with DuckDB for today, single quotes for strings, double quotes for columns. Yes? It's a great question, and another very, very good question. So the question was, just repeating for the recording, what's the convention around spacing in SQL, and what's the significance of new line characters and things like that in SQL? In SQL, you can have as many spaces are the same as one space, as many enters are the same as a space, so enters and space are interchangeable. That's nice because sometimes you're just sending a string of SQL off to some system, so you don't have to format it in any particular way. As long as there's at least one space, you're good. There isn't necessarily a great convention. Everyone differs. There are SQL formatters you can grab in your editor of choice like VS Code. We want to add a SQL formatter into this. We haven't yet, but that's the plan. In general, like to kind of space things out where each column or expression gets its own line, typically. Usually means there's a lot more vertical scrolling in SQL than otherwise, but it keeps things nice and separated. So that's my rule of thumb. Jacob, what's your go-to?
I'll just add a little bit more. I won't go on mic. But for those of you that do really care about like linting your SQL, there's a couple of libraries. One of them is called SQL Fluff. Yes?
Can you talk to the mic?
Okay, sure. Yes, I will talk to mic. Okay. So in terms of conventional SQL, I'll just repeat what Alex said, which is the parser doesn't care. The conventions that we write are really for humans, right? And so there's some libraries, one of which is SQL Fluff that is fairly common around enforcing linting rules on top of SQL. None of them are strictly necessary. The parsers are very good at interpreting it. And one thing I will call out too, which may not be super obvious, is a lot of times people like to use capital words for their keywords in SQL. That is totally unnecessary. You can do it if you want. The parser does not care. It does matter, however, for column names.
Not in DuckDB.
Well, yes, true. not in DuckDB, yes. Yeah, so yeah, that's the story on convention. Do what you like.
Yep, the capitalization of the keywords kind of comes from the days before syntax highlighting, 49 years ago or so, right? Right. The typewriter written papers, okay? Like SQL's been around. I tend to not like my caps lock key very much, so I just do all lowercase all the time. Snake case, it's a beautiful thing. So I'm aligned with Python on that. Excellent questions, thank you. So we'll kick us off into another exercise here. Please grab all the columns in our table of weather, but only for this one particular station name that we've listed out. And you should be automatically in instant SQL mode, so you should start to see the SQL be executed as you type. You're welcome to go in and out of that mode as you see fit, but I just am so addicted to it, so had to share. Anyone need any help in the meantime?
Develop this including the error messages that it gives, and because it gives you hints. I'm noticing when I type something wrong, it's like there's an error here, and it suggests a change to fix it. Is that part of what you guys designed in the UI? Like here, I tried is, and it's like DB equals.
So because you're logged into DuckDB, we added some AI functionality, so it passes the error message from SQL into like a little parser that just says, oh, I think this is your problem.
It's pretty cool.
So that's only going on using standard DuckDB. You don't have to use the AI function, but that's just included.
DuckDB is created by MotherDuck.
No, DuckDB is created by a company called DuckDB Labs.
Oh, okay.
And,
So MotherDuck is like this UI on top of that.
we are building a cloud service on top of this.
Okay.
Yes.
Very cool.
Yeah, that's one of my favorite features of the seats.
Especially when you're learning.
Yeah, correct. We will get into that when we get to the next.
Like monetizing something's been around for a long time, like something Fortran gives you an error and it's just like, no.
Yeah, the seats are really pretty good, but
Oh, really?
they can be sometimes there's some interesting type issues we run into.
Anyone want any more time? Just raise your hand if you want some more time. Sweet. Let's roll. So how are we going to filter down our rows? So I'm going to copy again, select star from weather, because I want all my columns, because I'm going to use the star. And you can see my preview is already run here, which is pretty sweet. And so how do I do a filter? I don't type filter. That's a different thing in SQL. What we want is where, and we want where our name, which is the name of our column. And you saw in our autocomplete there, it was giving us double quotes around name, because that's a column. So you could do double quotes if you wanted. I'm going to save a few keystrokes, and I'm going to also steal with pride this example from the actual question itself. And I don't even need to run it. It's already run it because of Instant SQL. That's all there is to it. Now we're able to slice and dice and see exactly the data that we want.
So classic SQL would require the double quotes around name?
Typically, no. SQL does not require the double quotes except if there's a special character or a space, or some databases require it if your capitalization is not lowercase or uppercase. So if you have like a mixed case, camel case column, sometimes you have to wrap those in double quotes. DuckDB is more flexible.
I'll add a little bit to that, which is it can get a little bit hairy when you're using reserved words, in which case you see the word name is highlighted blue. That's a reserved word. And so DuckDB is very nice with using it, but some other dialects will require you to quote that, for example. So in this case, it's going to return the exact same thing if it's double quoted or not.
And I wrote it in, SpongeBob case here. No problem. Good questions. All right. So here we're looking at specific columns. This we've already covered. So this is, instead of select star, we're just looking at whatever list of columns that we actually care about instead of grabbing them all. And again, this can be helpful if you have a very large data set, or if you have so many columns you're tired of looking at them all. Really helps to narrow down on what you're working on. All right, so here we're just going to play around with that a little bit. Grab a couple columns out of your data set. So feel free if you want. You don't have to run this describe query. I was about to show them that panel, man. You can also see all of your columns again in that left-hand panel here if you want them for reference. If you've clicked on weather, which is the one we're working with, you'll see all those names, so you can just start free running. But if you also want more visual space, like if my description doesn't go all the way over.
Yeah. Sorry,
It's, hey, go team. And if you haven't played with it yet, comment and uncomment is command // just like VS Code, which is really nice as you're poking around. Just like look in my direction, give me a smile nod when you're happy. I think we're pretty close. Let's have a quick look here. Maybe we take a quick break. Maybe one more example. All right, we've actually got another exercise here as well. So what we'll probably do is talk through that real quick and take a 10-minute break. So the next exercise here is we're going to use both the selecting just the columns we want and the rows we want. Just some practice getting a feel for it. So grab just these couple columns and look at only the rows where the values are, where both of these values are under 60 and above 50. So you're going to have to combine a couple of filters in your where clause. Sweet. So have a look at that and take a break as well. We'll see you back at 10 minutes from now, which is 9:11. And ask us questions throughout the break.
9/11? 10 minutes. Let's look at what you're seeing. It's a good question. The library is used for text matching, but it's not. It means if you're used to working like better analysis than
Oh, you're right over.
it's not great, but it is not precise. It's a very yeah, like what context is it?
So I don't need the word describe.
You're working on.
It is not clear, it's great. So it was sort of like an iterative suggestion. You step one, describe, once you see the columns, clear that out.
Yes.
So then this is what you ultimately
Describe is not that common of a keyword, it's mostly just helpful to kind of see what you have. But since we have that on the left-hand panel, it was easy to describe.
So whenever you have instructions with no code or writers, except for reading or
That's one way to do it. There's also a.
like this one, did anything happen when I clicked on this?
That is one of the gears of page size is where between 50 and 60. Excuse me, you want to go back and see them, there's a separate notebook, so if you scroll to the top left, each of these sections has an answer key, so it's made of 60, and that will have the exercises. Those are the spots where you can.
Because I was like, is something happening when I clicked on that? Because it was like giving me a notification.
The exercises are ones where, for example, you can, coach quiz. Do you want that on right?
Oh, I think 50 and 60. What you think? These are exercises, right? So 51 and 60 are being done. 51 or sorry,
Question.
yeah, yes. There you go. Yeah. Exactly. Yes. Yeah.
So it is a between keyword.
Yeah.
You could say, where this column between this and this, but it's not exactly as standard as Python.
I do like the
fact that
just change
The
it.
parser is very yes. Why is this keyword different in the context of that? Right?
Oh, if you move the arrow key up and down, enter will work again as your selection, but a lot of people just use enter when they're spacing things, and we didn't want to grab and bring it to
That's definitely the first one.
It should be between the number and spaces. Hey, good. I remember it. I don't use between very much. Everyone picks their own little famous SQL, and I have like decided that I don't use between, because I can never remember if it's inclusive or exclusive set.
Yeah, you're still with that.
Ah.
It's like, why is it
It's
just
confusing to me too, the inclusivity.
It's just enough where like I didn't want to memorize it. I memorized a lot, but that was one too far for me.
Yes.
I don't know. It's just not here. And I love my little, everything else.
It is confusing because it is inclusive, but between should be exclusive.
Yes. Yes. But, right, you were asking all the right questions.
Yeah. It also overloads the word and, right?
I know, yeah. What were they thinking? Man, those people 49 years ago. It's like, tell me when you're this one. It's too late. It's too late for us.
Yeah, exactly.
Yeah.
You want water or anything?
I think I've got lunch. I filled up my whole water bottle.
Just kicked our projector.
I've already done that once today, you're fine. Is the font readable, by the way? For people, especially people in the back, and people not. It's a little small in the back. A little small in the back? Okay, let's see. All right, we can make that work. All right, beautiful. Yes.
I just had a request a few weeks ago, so I'm probably going to extend it. I don't think I was falling asleep. It's a good, all good presentation.
How's the meeting?
It's hurting today, but then I put it through its paces yesterday at the airport and stuff, so. Otherwise, it's not so bad.
Yeah, I totally get that.
Yesterday was my first day with over 10,000 steps in a long time. so-
Okay. Okay. Yes. Oh, okay. Other questions?
Yes, but also my we are. We're fully web-based. My guess is if your machine suspends, it will probably close the code space. So just refreshing it, and then you should. We can. Sections just.
All right, welcome back, everybody. Let's take a quick look at these exercises, then we'll keep on rolling. So thank you for following along with us and getting a little bit comfortable with the new language here. So we wanted to grab a couple of columns. So I am in going to be in instant SQL mode. So I'm going to start with, let's say select star, because I want everything first, from weather. And so now I get some preview results. Now I only care about a couple columns in this case, so I can play around. You'll saw my habit was I hit enter and tabbed in. That's just how I like to format my SQL. So I could do something like my name. I could do my temperature min, something like that. And again, we also have the same, lovely discussions of 2 spaces versus 4 spaces. That doesn't go away in this language either. Pick your favorite, no problem.
You want to talk about trailing commas just for a second?
Sure.
Just for emphasis.
Yes, so in DuckDB, we believe that SQL should be friendly. So there's a couple of blog posts you can check out on friendly SQL. I'm very biased because I put those together. But, man, I couldn't say that subtly, could I? But we really think that it's a 50-year-old language. It's time to sand down some of the rough edges. So some of it is, trailing commas, for example. You can do those in DuckDB SQL. Most other dialects will be like syntax error around comma. And you're like, what gives? Where is this? So watch out for that. That comes into play a lot when you're commenting or uncommenting things, because in other dialects of SQL, if you uncomment your final column, suddenly you're going to have a syntax error when you go rerun because now you have a trailing comma on your second to last one. So that's just one thing to watch out for as you're playing with SQL in the databases at the day job. Sorry?
Or if you want to reorder them.
Or if you reorder your columns, yes. So if you were to take anything and place it after the last one, if you didn't have the trailing comma, which we can simulate that, right? So let's say this was our last column, and then we added this. It's going to say, hey.
Actually, it'll run in a very weird way, right?
Oh, shoot, yeah.
This is even worse.
Okay, so what is happening here? Yes, thank you, Jacob. All right, so we're gonna get down a very, very short rabbit hole. So SQL is very space-oriented, like we talked about. Spaces are significant. And one of the things that it did to try and be very, very helpful is it did something very implicit. It's the opposite of Python's ethos of being explicit. And what it does is if you space separate a column name with another word after it, that becomes a rename of that column. Right? That is now the new name. That's probably not what you intended, right? You probably meant to put a comma in there so you had both your columns. So what the best practice is with SQL is to be very explicit and put the as keyword here. And that is your rename command in SQL, is I want to select this column as my new name for it, and that is much more interpretable, and people tend to like seeing that. We'll also see in joins, we don't even follow our own convention. So you can alias a table in the same way as a column, but I have basically never seen someone say from weather as my table name. People just put space W, and they just rename it to W. So with tables, don't put the as. With columns, put the as. Simple, right? You'll get the hang of it, and we'll see it as we go.
Yeah, this is the convention thing, right? Totally optional.
Yes, totally optional. All right. Thank you, everybody, for that little bit there. Sweet. So the other exercise that we did during the break is grab a couple of columns and filter down to an interesting set of filters here. So let's start out with select. Well, usually what I start out with is writing my from statement. And luckily with Instant SQL, it's going to actually run my from statement because that's valid in DuckDB. So nice little ergonomic there. Then I'm going to select a couple columns, temperature. I'm going to do min and then max for sanity here. Sweet. And then let's do some filtering, and we do that in our where clause. You'll see now that I'm actually doing the typing, I'm not capitalizing anything because I don't like holding that shift key down. And so I want to see where both of these values are under 60 and above 50. So let's start with one of them. So I want temperature min to be less than 60. And if I want both things to be true at the same time, I'm going to use an and keyword to connect them. And there's, again, different decisions you can make on formatting, but we'll go ahead and do it a separate line for clarity. But it's under 60 and above 50, which is a little odd order, but I think it's to prove a point, which is you can put it in any order. Okay, so now I have where one of my columns meets these criteria. Now how do I add the other? Once again, I'm going to chain it together with and. So I'm also going to say where temperature max is greater than 60. That's the wrong thing. I meant less than 60 and greater than 50. And now we have just those temperatures. So it means you can mix and match a lot. If it does help, parentheses are optional, but it can also just be helpful to kind of compartmentalize things if you would like. If I do that correctly. Did I do that correctly?
That's right to me. I think
Yeah, okay. So you can optionally add parentheses if you'd like. Yeah. All right. Any questions on those exercises before we keep rolling? Sweet, so we've grabbed columns, we've grabbed rows. Let's start to do some calculations. So the first thing we're going to do are calculated columns. So a calculated column is going to have a value in every single row, and we're just going to add it as if it's another column, but it's going to be an expression instead of just a column name. So in this example, our expression is we want to see what's the average temperature of the day. So we're going to take the max and add it to the min and divide by 2, and this is our rough approximation of an average during that day. So once again, spacing is not super significant. You don't have to space these things out. You could just say divided by 2 with no spaces, or you can have as many spaces as you'd like. But in this case, we do want those parentheses for order of operations. And here we're seeing this rename come into play. Well, we are using that as mean temperature. What would it look like if we didn't have that? It will still run, but it's going to auto-create a really lovely name for us. So if you, as we'll see later, you often end up referring to column names in future calculations. I don't want to have to refer to that in future calculations. I'm going to have to wrap it in double quotes. I'm not going to be able to remember it, so I want to have it a nice, friendly name. Yes, question?
Is it creating a new column in the table or just showing you that information?
That is a beautiful question, and I wish I had mentioned it. Thank you. The question for the recording is this creating another column in our data, or is it calculating it on the fly as it gives it back to me? And in this case, it is calculating it on the fly as I see it in my result set. So how would I know that? Well, here I'm running a select statement, and this is a retrieval operation in SQL. It says, pull the data out of the database and show me a set of results. If I wanted to actually edit the table, I would be running a create table statement or an alter table statement, which we haven't covered yet. But either of those will actually edit the underlying data in the table. If I want to save this data, it is as simple as saying, create or replace a fancy, shiny, new table, which I cannot spell. That was dangerous to do that. I'm going to use this create or replace. I need the word table here. And then I give it a name. And then I use this as keyword, which has another name, another purpose behind it. And that says, create it based on this query. And this will now actually create a table and persist this data. By default, we're not persisting it. We're just kind of getting it back on the fly to look at the results. Does that help?
So are you going to add something after as?
I keep this query here. So I might indent it for, it basically says run this query and take the result and save it back into a table for me. Very good question. And that's part of, most SQL dialects have this. This is part of that kind of friendlier idea. Traditional SQL, you have to run a separate statement that says create a table with a column name of a varchar. Create the table with the column name date of a type date, and create another one, mean temperature of type double. And then you insert into it. And if you're using something like an ORM or other things that generate SQL for you, you might see those things because that's very flexible for something to programmatically generate for you. But as a human, working through my data science workflow, I want to take this result and save it for next time. I'm just going to use this create or replace table as. We colloquially call this a CTAS, create table as, CTAS. I think you had a question next. That is another amazing question. So the question was, what is the math convention that is followed in SQL for the various operators? Is it doing integer math? Is it doing floating point math? What's going on? Does it use data typing? This again varies by databases. So I didn't use this joke at the beginning, but SQL does not stand for standardized query language. It stands for structured query language. As much as we want it to be the standardized query language, it's just all a little bit different flavor. So with DuckDB, this will automatically, this single forward slash will automatically detect if you're integers or floating point. I think it will always do the full floating point math. If you want it to do integer math, you do double slash, and it will truncate. That is not consistent across dialects. DuckDB actually had a breaking change a few versions back where they changed it to this from the other way, so it's very much up to the database. In general, SQLite, if you're familiar with SQLite, is very famous for having no typing. It is fully dynamically typed. It is very difficult because you can have within one column, you can have some numbers, some strings, some dates, and oh man, it's great when you're putting the data in, bad when you're pulling the data back out. DuckDB will have types of columns, and it uses that to also go a lot faster because I can do integer math a lot faster than string math, stuff like that. So in general, it is nice to think about your types of columns. Thank you for the excellent question. Another question went up here.
Yeah, so you're showing us how to create a new table. Which command would you use to add a new column to the existing table?
That's
a couple words, like insert or something.
Yes, that's a great question. In general, as a data scientist, I did not add columns very frequently because I would find it to be almost as fast to just create and replace the whole table with my new updated value. Part of that is I'm spoiled by DuckDB, which is just so daggone fast. I just do that.
Create or replace table weather as, because this one here.
I could do that, but then all my examples will break. But yes, I could do that.
Okay.
You're exactly right.
I can add a little bit to this too. So like the thing that we haven't talked about at all is this notion of views in SQL, which are basically canned select statements. And so really when you're thinking about like a data science workflow, what you probably would do is create a view. And that view does not materialize the data in the database. It's just basically a pointer to that select statement. And so that lets you kind of build fairly complex math and keep it in your database, but also not materialize all the data behind it. We don't really talk about that, I think, in this tutorial, but like that's kind of generally what we would do. And I think we talk about CTEs later, right, Alex?
We do.
Okay, so CTE is the other way to do it, which is common table expressions. We will get there later. But like in general, I would not say that in specifically like data science type workflows where maybe you're coming from Python, alter table, you probably don't need to worry about it too much. And in general, even in a database like DuckDB, what you'd want to do is actually create a new table anyway. It's a much faster operation than altering an existing data structure. So, yeah.
So it's an excellent question. Thank you for asking. It is very, very possible, very doable. It tends to be easier to ignore the alter table.
Indeed.
But thank you for asking. Other questions? Sweet. Ask anytime. These are very, very good questions. Much appreciated. All right, we have an exercise. Get some fingers on some keyboards. So we're going to add a new calculated column, temperature underscore range, and it's going to get the difference between min and max. Just get a feel for that syntax. And there's another exercise as well. We'll do them together in a combination. You're going to create another calculated column where we're going to use a system of measure that makes sense, and we're going to convert to Celsius. So please go ahead and do that conversion as well. Raise your hands if you have questions as we have them.
Yeah. This is a weird because, it's very strange to store code in the database, right? So it's like you break a bunch of conventions with use.
Now, said another way, that was probably the original convention.
Yeah. I mean, it's actually excellent. There's just like a missing source control loop in there, right?
50 years ago, that was fine.
Yeah.
And if you, like me, don't ever remember how to actually convert to Celsius, feel free to create your own temperature scheme, whatever you like, calculate column. Oh, well, bonus points. We got stickers up here for Kelvin. How about that? All right, anyone want to raise your hand if you want a little more time? Okay, we'll do just another minute. Thank you.
I think for calculated column, if you have both data types of they'll do like an average calculation or something, the whole data type, if everything is typed integer, it will be integer. I'm pretty sure. I know SQL Server behaves that way. I'm pretty sure that you think it's doubles? Even if it's all integers? Oh, they did. Well, that's normal. Yeah, because I don't know what it is, but I just mean like other databases, if it's all integers, it keeps the like. Yeah, they keep everything as integers. It'll keep the final table, the final column to be implicit unless you specify it. That's actually a very interesting thing to talk about too, which I don't think we covered, but it's like no, because it's like you can do a whole day. We'll briefly talk about it.
All right, let's jump into it so we can keep rolling. Thank you guys for following along. Really appreciate it. Helps to get some practice in. So we want to add a calculated column called temperature range. So I want to pull this from weather. I have instant SQL turned on, so we see that we get some results here. And then I want to do a select. I'm actually pulling the min and max as well, just so I can see them while I'm working with them. And then I want to do some math. So we'll do temperature max minus temperature min. And then I want to rename it. So I could, if I wanted to, confuse everyone else that read my code, I could just say space temperature range, and I'd be correct. You see, I get the nice right answer, but it's so hard to read that. I would much prefer the nice big word as in between there, so I can rename my column in a way that is easy to interpret. One thing to keep in mind with SQL, part of why people are picky about their formatting is sometimes people are doing it in a non-syntax highlighted spot. It's a multi-line Python string sometimes. And so it is nice to focus on clarity with SQL. Code is read more than it is written. That is all we needed there. The next one, we wanted to create another calculated column for doing Celsius. So we'll do from weather. We'll do a select. And oh man, calculate complicated formula here. So let's see, this would be the observed temperature. So that's temperature obs. And this is in Fahrenheit, so I want to subtract 32. Whoop. And then I want to multiply by 5/9 as. Okay. Is that right? Except it's spelled wrong?
It's a C, not an S.
Is it an S? Okay, I'm sorry. Forgive me. That is a way to measure temperature that is better than our own. So there we have it. Calculated columns and renaming them.
Alex, does SQL respect order of operations?
It does. SQL does order of operations, yes. So you can wrap parentheses to force certain things to happen before other things. The innermost parentheses will execute earliest. Just like Python, just like math. Thank you, Jacob. Sweet. So last piece in kind of our initial section here is sorting our data. Another common workflow where a lot of SQL is the very last step before the presentation layer, or you're playing with your data and you're exploring it with SQL as a part of how you're looking at it. So frequently you want to sort it, and we do that with another clause. So another clause in SQL means we have a space or an enter. I do recommend an enter just to keep it straight. And then we're going to have the words order space by. So SQL parsers are somewhat difficult to build because we have multi-word keywords, which I don't know why they couldn't have just done order underscore by, whatever. Fine. Order space by together is one keyword, which indicates this clause. And it is too late. It's too late for us. So in this case, we can grab any columns that we like, and we can order by any of them. And then after that column, we're going to have a space and have either ascending or descending to determine what order we want it sorted in. If you leave it blank, it defaults to ascending. And so here you can see precipitation of 0. If I then change to descending and rerun, we will see we've got some precipitation there in order. Some databases also will allow you to sort by results that aren't even in the statement. So I'm sorting by a column that I'm not selecting. It's a little interesting, right? I can sort the data and then not even show you the column I sorted on. Some databases will get a little grumpy with that. It's not a great practice. Usually if you're sorting by something, you want it in your select statement so you can see what is happening. So I would recommend, including whatever you're sorting by in your select. You can also order by multiple things. So if I wanted to start by saying, my first thing I wanted to look at is precipitation, and then whenever I have low precipitation, I also want to sort by, temperature descending. You chain those together with a comma. So it's a little different. So it's kind of like listing of columns we see in the select statement. In the where clause, we don't use commas anymore. We're connecting with and or because we need to have that Boolean logic, because we don't necessarily know what the comma is. Is the comma I want the intersection, or I want both in the Venn diagram? So we have to use and or in the where clause. In the order by, it's another list of columns. I just want to order in order of these expressions, and so we can go back to commas again and order by this, comma this. And that's how we order by multiple things.
What's the default order if you do not specify an order?
Oh, question for the audience. What is the default order if I don't specify? Ascending. Thank you. I slipped it right past you. Sorry, Jacob. But thank you. Yes, so that is ordering in your database. So we'll do a quick exercise there. Use the query you created in the previous and order by precipitation in ascending order. And we have another exercise, which is kind of combining things together. Grab a particular couple of columns and sort the table so the row with the lowest temperature is at the top of the results. And then we've made it through section 1. Now on to the crazy stuff. We're going to wrap it up.
Okay. Not doing this or something. Let's do it again. Good compromise.
Anyone looking for more time? Raise your hand. Okay, we'll give it just one more minute. Thanks, everybody. All right, let's jump into it. We got a lot of fun stuff coming up. All right, use the query in the previous exercise and order the rows by precipitation. So I think we were just going to copy this and just change the sort order. Okay, looks like I already kind of played around with that, so you kind of saw that as an example previously, but just changing from ascending to descending. And the next expression, we're grabbing a couple columns and we want to sort it. We tried to make this into a word problem, so let's see if I can remember how I did the own word problem here. So we want name, we want date, we want all right, and now we want to order it. So we want order by where the lowest temperature observed is at the top. So we basically wanted to say ascending without saying the word ascending, so that way you guys had to think through it one more time. Sweet. So we've got it by ascending. Questions? Questions? All right. Thank you for following along. Really appreciate it. So what we're going to do now is if you've hidden your side panel, go ahead and either click on this icon or hit Command B to open that back up. And we're going to move on to another notebook. We're going to move on to SQL Training 2A, Group By. And I think this is where things get fun, if they weren't already. So in SQL, what we've done so far is grab the data as it exists out of the database. We figured out how to be precise with how we retrieve it and then order it. But now we want to start doing some more calculations on it. And the calculations we've done so far are kind of row by row. You have the same number of rows that you get back as were in the original data set. Now we want to do some summarization. We want to go ahead and aggregate our data. And we call aggregates, in SQL, we call it the group by clause, as we'll see. So to do this, we're going to grab two new data sets. So you can run this attach command if this is if you didn't run it already. And we're going to create two new tables. And we're going to do the same trick. Mine says, hey, it already exists. So what's our trick to get around that? We say or replace. And then I've recreated my data, pulling it from a couple of CSVs. So this also includes one other trick that we did not talk about as well. There are two SQL statements that are separate in this box. How did we know that they were separated? SQL statements are separated with semicolons. And those are buried all the way up to the right-hand side, hidden. So if you wanted to run multiple statements, you can separate them with semicolons. You'll only see the final result from the bottom query that you run. So typically, we're using a separate cell in the notebook. You can think of it, you could use semicolons instead. A little nicer to have a separate cell for us. But semicolons are how you delineate technically the end of a SQL statement. It is best practice to avoid them unless you really need them, just like in Python. Technically, you can end your lines in semicolons. But don't do that.
Back to convention, I will just call out that you can put the semicolon anywhere you want. And so it can be 3 lines down, it could be right behind it, it could be right before the create or replace, and it will work. So yeah, when you're reading SQL, especially things generated by machines, you will see crazy things like this.
Thank you. And we've kind of been seeing them all along, didn't explicitly talk about them. We also have comments in SQL, of course. One-line comment is dash dash, and a multi-line comment is /**, asterisk, // So we've kind of been seeing them all along. You can add those anywhere as well, so semicolon is here because. So we now have two tables. You can summarize them here. Summarize is kind of the SQL command to, it's not consistent across databases. It's another kind of helper thing that DuckDB adds for us. And it looks a lot like what we see in the side panel. You have some approximate counts. You've got your quantiles, your percentiles, and how many nulls, how many missing values are there in your data. So if you're not using this UI, you want to get a quick overview of your data, summarize keyword is your friend. Otherwise, you can just use the same side panel we looked at before. And instead of clicking on weather, you can click on birds. Because, of course, we're wearing the shirts. Gotta lean into it. And then we also have a table called ducks because we have to. It's required. Thank you for joining us in our feathered fun. That's all I got for duck jokes for now. So we can also summarize this and get a sense of what's in our ducks table. Ducks is just a couple of rows, just 140 rows or so, I think. And we have about 100,000 rows in our birds table. Okay. So here we're practicing our create table command again. I'm going to go ahead and skip this because we got some good practice of this before. This is just rerunning that create table statement with a new name. But it's not necessary. We're going to be using the original name for all the examples. This was just practice. Similarly here, we were just giving it a new name. So I mentioned already the group by clause. We're actually going to start by not using that quite yet. We're going to use aggregation functions to start. So an aggregation function is different than the calculated columns that we used so far. So far it was row by row. This is actually going to change the number of rows in our result. What this is actually going to do is bring it down to just one row. It's going to summarize our entire data set down into one value. So I want the minimum of this entire column, and I want the maximum of this entire column. And so we get back a one-row table, a summary of the entire data set. So in this case, I'm doing an aggregation. But there's no keyword aggregate. There's no keyword grouping. how did we know we were doing this? It's because of the names of the functions. It's a min, it's a max, it's an average, it's a sum or a count. Those are aggregate functions. It's just part of the syntax of SQL to know that those functions will look across your data and aggregate it up across a column. So that's the kind of behind the scenes that's happening there that is making this happen. So those are our aggregate functions, and we will do an example of those shortly, but we tend to like to mix and match these with our group by clause. So a lot of times getting a single row of output is not that helpful. A lot of times in data science, I want the average by a particular category. You know, average by bird species. How big is it? Well, it's not usually useful to average eagles with finches. We're leaning into the bird metaphors here. So we want to group these together and split them apart. So we do that with a group by clause. So within SQL, the ordering of the clauses is generally important. We heard the exceptions from DuckDB where we've got some friendlier things, but in general, the order is still important. So we're going to put group by after our from and after our where, if we have it. So we're going to grab our columns from our table with these filters, and then after that, we will describe how we're going to group it. And here we're going to group by our species. So we want to understand by species, by this grouping, I want to calculate some metrics for every group. And I'm using average. I could have used min, max, count, anything like that. And I am also including the name up here as well, and we'll talk about that in a moment. So here we can see we get much more than one row back. We get one row for every species. And then we get our metrics for that species. In SQL, I am not required to include this grouping in my query. But it sure doesn't look very interpretable to me. So highly recommend that you align your select statement with your group by statement so that it's very interpretable. This has a darker pattern as well, where I could accidentally also group by something else. I could group by, do we have name in here? Nope, name's not a real thing. We can group by anything arbitrary. And what will happen is I'll end up with a lot more rows, but I'll just have duplicate values of my species with different averages, and I won't really understand what's happening because I'm grouping by something different than my select. So this is something where SQL violates don't repeat yourself by design. It's a bit stressful, and it's a common critique of SQL. You have to update it in two places, so it's a gotcha, a watch item. DuckDB, once again, it's our knight riding in his shining armor. We've simplified this because we've hit our heads on it too dang many times. So while you're here, spoiled in DuckDB land, instead of specifying what columns you want to group by, you can use the keyword all. And now you only have to specify your groupings in one place, in your select statement. And we're going to basically figure out which columns are not wrapped in an aggregate function, and I'll group by those. So species, that's not wrapped in a function. We want to have, return every species, group by that, and we'll automatically run that same query with group by all. And I think that's a little bit more about how I think about it coming from other things. Yeah. Like in pandas, you don't have to specify it in two places. So this is kind of aligning with a lot of the data frame syntax. All right, questions on group by? One or two more examples, and then we're going to get to play with it. Yes, question? That's a beautiful question because it's this example, and we are doing it. So, perfect question. So the question was a perfect lead-in. What if you have multiple columns that you're grouping by? What is SQL going to do? Perfect question. And there's what it will do is it will get the distinct set of combinations of them. So in this example, we've got countries and sources of these birds. And it is not going to do all combinations that are possible. It's going to do all combinations that actually exist in your data. So for example, I'm going to add an order by here just to make sure that I'm speaking the truth here. So for example, you'll see that Algeria has a lot more sources than Afghanistan. So it's not getting all possible combinations, it's only the ones that actually happen in the data. So it is reading through the data, and it's remembering all the unique combinations that it finds, and recording the maximum as it goes through your data. So what do you think about it? So it's kind of your actual. So pandas, if you're doing something like a group by or a pivot table, you have multiple options. All combinations or the ones that actually exist. SQL always does only the ones that actually exist. Yes?
So the all command, the doesn't usually do the same thing, or aggregate was, so we don't have to do it for the just one,
Excellent question. So how does the all command react with multiple? All is going to write the exact SQL that we have here, and it's going to use both. So it's going to be equivalent. Generally, let's do a quick experiment. So what if I only grouped by one of these? DuckDB is going to say, I don't know what to do with this. You want me to show you a value, but I'm not aggregating on it, and I'm not splitting it into its own group. What do you want me to do? Do you want a lot of rows, or do you want less rows? And so it's going to have you, the user, make the choice. And you have two choices. You could add it back into the group by, or you could remove it, or you could wrap it in a function. So maybe I actually want the minimum source, or maybe I want just a random one. Maybe I want the first. So you as the user get to choose how you want to handle it in those cases. So I'm going to back it up just a little to kind of our more traditional example here. Great questions. So this is grouping with multiple columns. It is looking at the actual combinations of things that are seen in the data. We saw you could have multiple non-aggregated. You can also have multiple aggregations as well. So if you wanted to have a min as well, you can do that. And you'll see we didn't assign names to them, so they're kind of ugly names, but still give us the answers. Do you have something?
I was just going to add, as we think about group by all, and one thing that Alex called out that's really critical is that because it's only kind of returning data sets that exist for those combinations, we're basically defining the cardinality of our data set, right? And if you think about how this works with maybe dates, if you're using some sort of like time series type analysis, the common trick in SQL is you often will create like a date spine or something that you're joining into so that you get a fully hydrated kind of list of dates. I'm just calling that out because it is an easy trap to fall into and wonder why your data looks strange because you skip dates. So, yeah.
Yes, it is only what exists in the data. So if your data is missing data for a date, it will not be in, there's no group for that. So that's something to watch out for. Thank you, Jacob. We might have run into that a time or two. Anyone writing SQL? Yes, yes, I have experienced that pain. All right. I think we got an example here. Yes. So let's write a query that gets the average of a few metrics across all of our birds. And then we want to find an average of a few different metrics by a few columns. We want it by species and by country. So the combinations of species and country. And raise your hand as you have questions. Have a go.
I mean, you could just be like, sometimes you may see this like an O on it, and you just, I put my position. Is that valid? Yes, because it's strange. That's, shouldn't do it. No, avoid it. But not too much. Okay.
All right, who'd like some more time? A little more time? All right.
I suspect it could take a while for my setup to work.
Definitely want to break there.
So, why don't we put it out there? Like circle this section. Let that people take a break.
We'll just have these no joins.
We have two documents.
I didn't know that.
That's fine, that's fine. You can fix it. That's fine. That's fine. More so. We'll see. Just be like, it's obvious. Sweet.
All right. Anyone want any more time, or shall we jump in? All right, let's jump in. Thank you, everybody, for giving this a shot. So, let's say we want to run a query that got an average across an entire table. At that point, we are just going to use our aggregate functions. So I'm going to select from my birds this time, not weather, and I'm going to grab average. It is AVG, not average spelled out. Again, not my call, but that's saved us a few whole letters of typing. So we got AVG, and we're going to do our beak length.
Really matter in the 70s.
You know,
Needed those bytes.
I mean, golly, saved so much. Okay, got our average wing length and our average tail length. And by not specifying the group by, I look across my entire data set, and I get those averages.
Can you have the count just to amuse me? So
Yeah, let's see. So this is a sample, for example. I'm in instant SQL mode, so we're looking at about 5,000 rows. If I were to run this in its entirety, we've got about 90,000. So just while you're in instant SQL, while you're playing around with it, to make that super snappy, we're just sampling your data. So if you wanted to report out on these averages, you do have to click the run button. All right, so now let's do something a little more complicated. So I want to find an average of our tail length by a couple of different values. So we'll do from our birds, and then we'll go back up, we'll do our select, and I want and this is again another convention, but one convention in SQL is to have your, try and keep together the columns that you're grouping by and then your metrics separately. So if you think about it like a pivot table in Excel or a pivot table elsewhere, you typically on the left-hand side are going to have your kind of categories, and then your metrics are off to the right. That's how I like to write my SQL as well. So while the problem didn't specify it in this order, I'm going to start by saying my species common name, if I could spell it, which, thank you, autocomplete. And then I'm also going to have my country here as well. And now I will add in my average of my tail length. And what I'm going to see is an error message. Hey, you need to have a couple things in your group by. So thankfully, this is at least a useful error message. It says, hey, this column has to be in your group by, or you have to wrap it in a function. So we want it in the group by. And I'm just going to cut and paste, since I kept them nicely together, both of the columns that I wanted to group by. And a trailing comma, look at that. Hey, beautiful, copy paste. All right. Any questions on those? Sweet. So within DuckDB and many other databases, there's all kinds of powerful aggregation functions. You can do, standard deviation, your kurtosis, all kinds of statistical aggregates. You can do percentiles, a lot of very powerful different ways you can aggregate your data, even though we're just looking at averages, counts, and sums for the moment. Oh man, I should have moved down. We're going to do a more advanced one. So we're going to do quantiles. So this is, I think, a very useful thing. I think I've gotten into trouble in the past looking at averages when I should have been looking at medians. So this is a good tool to have in your toolbox. This is just another aggregate function. But in this case, I have another parameter in addition to the column name. So I want to take a quantile of a particular column, and then I need to specify some number from 0 to 1. That's the actual percentile I want. So I want 95th percentile, so I specify 0.95. And that'll get across my whole data set, because I have no group by, what's the 95th percentile length of a beak? And I think this is millimeters, so it's like a, I don't know, pretty big beak at the 95th percentile. We're talking, you know, like pelicans. All right, so that's our quantile. And there's a quantile continuous and a quantile discrete. So that's what this CONT here is the continuous version of the quantile. All right, a couple exercises. Grab the 95th and 99th percentile of this column. Let's just do the bottom one. Let's just do exercise 2.06 just for time. Just grab the 99th percentile of wing length by your species. And then we've done group bys. All right, and we'll go ahead and take a 10-minute break as well. So go ahead and wrap up that exercise. We'll cover it as we come back, and then we're going to do joins. The chapter I read a couple times. We're doing it in like half an hour, so we're doing it. I'll come around for a question.
No, it's just a question.
Okay. Yeah.
Maybe it's interesting for
Please.
Can you also create your custom functions, and if so, what's the syntax?
Excellent question. So the question is, can you create your own custom functions, and what is the syntax for that? This is another area where it's different in every database, unfortunately. There's some standardization, but this is a concept that's kind of been bolted onto SQL a little bit, so it's a little different. So some SQL platforms actually allow for Python functions. You can do that in DuckDB. You can actually create a function in Python and invoke it. You cannot do that for aggregate functions. You can do it for what are called scalar functions, which is one row at a time, or table functions, which is the whole table, which we haven't really covered, but you've secretly used them. The read CSV function is a table function, because I'm grabbing a CSV and I'm turning it into a table, so you get both columns and rows. So that was a table function, but we snuck it past you. Sorry about that. So you have those couple APIs for Python ones. There's also ones for SQL. So you can say create function as, and have a SQL statement that defines your function, and that can be either a scalar value or it can be a table value function. So they're the same. So in DuckDB, there's another keyword for it. You can say create macro. It's the same as create function. It's just another keyword. Other databases have more advanced capabilities here. So another common one is called a stored procedure. If you've heard of that, some people consider it an anti-pattern. I personally am on the side of it being useful when done judiciously. It can save a lot of round trips back and forth to your database, so it can actually be a very, very performant thing, but by default, it doesn't use source control, so you got to use source control with it. That's sort of the requirement to make it not an anti-pattern. DuckDB does not have stored procedures, and the reason for that is because we talked about it very briefly at the beginning. DuckDB is actually running inside your Python process. We're going to see very soon the power that gives us working back and forth with Python objects. What that means is you can just have your procedure be inside your Python script, and you can kind of have the Python procedural language take care of the procedural side and just have your separate SQL statements baked into your Python. So that's why DuckDB hasn't felt the need to build their own procedural language. But something like Postgres has stored procedures. So that was a very good question and a very long answer. Does that help?
Okay, thanks.
I can show you some links. Awesome. And so that comes back to one thing that I'll leave you with before we take our quick break, which is, as we've seen with SQL, we're not telling it how to calculate things, we're telling it what we want. And that means it's a declarative language, whereas Python is an imperative language. Most languages are imperative. I'm going to specify a loop. I'm going to specify an if statement. I'm going to tell it exactly how I want the program to run. The database has some flexibility here. We just told it to group by something. We didn't tell it what algorithm. Is it going to loop? Is it going to use a hash? The database is going to choose. And it actually sometimes uses both, back and forth, depending on what's more efficient. So this declarative nature is a little different. So let's take a couple-minute break. See you guys back here in 10 minutes. Thank you for the question. Refill some water.
You want me to show you where the docs?
Yes, absolutely. Please.
Sure, so let's go to DuckDB.org. Documentation. And for the SQL macros, we go to expand out SQL and then expand out statements. There is a create publish. Yes, create access. So this is how you can create helper functions.
Okay. Okay. But you told me this is not a standard. This is when I use DuckDB, I use something else. It's something different.
Instead of the word macro, it'll just be the word function. But DuckDB's functions are somewhat the lowest common denominator.
Okay.
Most databases are going to have a create function, but some of them are more flexible than DuckDB.
Okay.
So for example, DuckDB is just one statement. Whereas in Postgres, I can chain together a lot of SQL statements and put it all in one big function.
Yeah.
So I can say, take data out of this table, insert it over here, take it out of here, insert it over here, and have it all in one.
Yes. And when you probably it is here, I just have to go through, but all the functions are returning something, or can I create also functions that just execute pieces of code that I might be interested in without returning? In this case.
I think it always has to return something.
Okay.
Yeah. But you can return very small. Well, you're going to wrong in returning the data. The reason is because it has to be one statement, you can't really just save the data and then return something different. To save the results, you have to say create table as run by function. And so as a result, you always have to kind of return it out of the function.
The last question
Is it great?
which is probably not so. Whenever because from this that you just told me, I would say that every time I run a function, basically it copies everything and then destroys everything at the end. Like a function will never effectively modify the object. It works only with R values. I don't know. Is it possible to have functions working with L values?
I kind of think about it two different ways. So SQL is, since it's declarative, you can think of it like a batch operation. So you can kind of run your calculations and save them to a table and then rerun them on the same table. So you kind of do that. There's also a concept, we'll get to something close to it in section 3, but in section 2. You can do recursion in SQL. So there's a with CTE, with a recursive CTE. And so that would allow you to do like tree traversal and things like that that are inherently kind of recursive. We're not going to cover that in a 4-hour crash course, but
Okay,
it's
I see.
possible.
Okay, I see. Okay, thanks a lot.
Excellent questions. Any other questions? I'll hand it back. Push it right there.
So, I think there's a couple of things back from this one. Group by two.
Sure.
I noticed the full grade brought back some nulls. Yes. Run, is that just a preview? Yeah, so if you get, oh, there we go.
Yeah.
That shows some, so I'm curious as to, are there just some rows with species with no country?
Yes,
Okay.
that's a great question. Yes, so the question was, what's up with these nulls? Well, somebody, this is like a volunteer data set recording bird sightings, and they didn't put in what country they were in. They just said, I saw a hawk. Cool, log it. It was this big. And then they moved on. And so that's a blank for the country. Mhm. Thank you for the question.
Good question as well?
Yeah, it's more outside of the UI, like, are we able to use, because I'm thinking how we can use it in our applications. Like, could we use it outside of the UI? Essentially what we're trying to do, one of our projects is, we have a bunch of CSV files, we want to bring it all in, put it into a database. So we just came up with putting it into a database. So it's still very new, but yeah, like what's the spin up with it outside of like the UI portion? Because we're Genoa, so there's a lot of like, I don't know. As you saw when you're on my computer, there's a lot of administrative stuff.
You guys use Python a lot?
Yeah, we're using Python, yeah.
You have the ability to pip install?
Yes, yeah. It was just
You can
install.
section, please.
Okay, perfect.
Yes.
Perfect. So I'm like, yeah, because we're usually using Postgres. But
Actually,
if this is faster, manipulate it a lot easier. Yeah.
Rule of thumb is, for like working with data science type of workloads, so we're making millions of those,
Yeah.
we're about 1,000 results.
Okay, that's good to know. That's, because I'm gonna be like, we can use this. Yeah.
And it's a mixed license, so like there's not put where you want, and we don't like run a cloud service, but also
Yeah.
whatever other nonsense, so feel free to start.
Yeah, yeah.
Maybe
We're
step
trying
around
to get,
soon, who knows?
we're trying to get to the cloud, but, yeah.
Yeah, no, the next piece. You can also, a lot of people you can actually use like in Bash, you can just do that from command line in Bash. So you can do like .cd -c and then just pass it.
Full time now.
Execute it. So that, and there's actually a Postgres return, right? It's built into that. So you can do something like a DuckDB operation, read from Postgres and write it back. So if you wanted to like just like move your transfer, maybe like your operational data is Postgres. Read all your data out, whatever data you need out, do some complex math on it, and
That's exactly what
yeah.
you're doing.
So
Yeah.
you can do that like we see lots of different lots of different ways. But like with orchestrators like Airflow, those have like a SQL.
That's a good question.
Runs a SQL.
So
I got it simply to use.
Yeah, thank you.
Yeah, of course.
So it's kind of
Yeah.
I've seen this online where it's just interesting, so we're trying to figure out how to treat these guys as operating context. So to that works. Using things in higher level, just as new. What does John do with the data set? Which I think is pretty. How does that work?
Yeah. So if you think about like what else so if you, I'm assuming you're doing operating on those, but you don't want to operate on concept.
No, ideally not.
So you want to operate on it.
So I'm gonna scratch my head here.
Whatever. We'll post the push down on the most predicates, most not all of them.
That's some manufacturing data.
You actually need to like find out things that are on your least supposed to be one period of the.
Okay, but why is this?
But yeah, you don't need to replicate the entire data.
Still trying to figure out.
You can just take the column and it will be have a memory load that you get to those
Make something like, let's say, fabricate something. I mean, real data. Still trying to.
100%, yes. Yeah, I guess the Postgres one is very mature.
We work a lot of engine on those.
And you can run that on obviously laptop, and you can also run it on like really big PC machines. So you can get like terabytes of RAM.
Run size distributions, shapes, and all kinds of things like that.
The next part's the fun part. You get to join the Python cells.
Which one use the whole?
Alex. I can run it.
Do you know which one is, lunches?
So,
Probably not on the way home. We're just
They have to be here.
Yeah, they said they were serving lunch. They said grab your own breakfast today and tomorrow, but there's actually breakfast.
okay.
That's what the email said yesterday.
That's great. I guess we can tell this one. Ready to start back?
Yeah, I just figured I'd populate this. All right, welcome back. We'll do a quick review of our last group by example, and then we're going to jump into joins. And then we'll do some subqueries. And then we will do how we work together with SQL and Python. So here, we wanted to get a 99th percentile by species common name. Kind of wanted to know what are the biggest of the birds by species. And what we wanted to do is in our select statement, pick the column we're grouping by, as well as have our aggregate function that's going to calculate values for each of those groups. And then we also need to include in our group by that particular category that we want to group it into. We could also cheat, and for the rest of today, this will work. You can just always say group by all, and you're good to go. So bonus extra credit. So you may see this in machine-generated code. I do not necessarily recommend using it, but if you see it this way, you'll at least know what's going on. SQL doesn't really believe in the only one way to do things that Python talks about, and in truth, I'm not sure that Python believes it either, right? We have a lot of different ways to do things, and it's more like guidelines anyway, right? So with SQL, you don't have to refer to things by name in your group by clause or your order by clause. You can order them by position. So I can say I want to group by my first column, and this will actually work. I'm grouping by 1. Like, what the heck? Am I grouping by the like actual number 1 and just, no, you're grouping by column position 1. What a mess. Not only that, but you can also, I think, do the actual number sign 1. No, you can't. What is it? Is it $sign? Oh, I could have sworn.
Prepared statements.
No, there's, I thought there was a way. Yeah, so it is possible to do it in other things. So watch out for that. This is very, very frustrating if you have to actually modify it. I've seen group by 1 through 15 with number 12 gone. Okay? Just, it's nightmare land out there. Once code has been around for 10 years, like, all bets are off. So watch for that. I mention it in case you see it, but not as a recommendation of what to do. So we are going to a new notebook. Everybody head over to 2B, or not 2B. We're going to go to 2B for our joins. So this is where we're going to heavily lean on analogy. Question? It's a beautiful question. The question is, ordering is a little bit different based on the statement that I'm writing with SQL. If I don't put an order by in there, Why is that happening? That goes back to a design decision of the SQL language, which is it deals with things. The original paper was talking about unordered sets, and they've now allowed it to be unordered multi-sets. What does that mean? It means you allow duplicates, so we allow duplicates. But DuckDB, all databases, their operations do not maintain the order of your original data set. Why would they do that? That's so frustrating. Like I kind of have this mental model of how my data works. The reason is for performance. I can spread things across as many cores as I would like if I don't have to worry about the order. So unless you put an order by, your results may be different, depending on, they're not guaranteed is the way to phrase it. Now, big exception. Once again, we're spoiling you today with DuckDB, okay? I am very, very biased, but daggone it, it's very friendly. So there are cases where DuckDB is going to do its absolute best to maintain the order for you. So if you're doing a select from where, we will maintain the order because you're not doing any aggregation and you're not doing any grouping. And we will just pass through the order. The same CSV file order will be the result set order that you'll see. It works also when you're inserting into a table that way. So if I want this table to be the exact same order as this one, you can create a table as a copy of it, select star into that new one, and the order will be the same, which is very convenient. That is not guaranteed in any other system that I'm aware of. The other aspect is as soon as you do a group by or a join, the ordering is no longer guaranteed. And the reason for that is the way that DuckDB does these operations are by hashing. When it does a group by, it does a hash, and it has a dictionary of all of your keys, and then it has your aggregate associated with each one. And while in Python, dictionaries have a concept of order, they do not in SQL. Or in C++, which is what DuckDB is written in. So whenever your order is important, you will want to specify order by explicitly. The other thing you might be seeing in our UI, if you're using instant SQL, we're giving you a preview. It might be a slightly different preview each time for the same reason. Excellent, excellent question. All right, well, let's jump into joins. So frequently, our data is not all in one place. I think the way I like to phrase it is all the interesting questions with one data set have already kind of been answered in 2025. A lot of the value is when you're combining data from all over the place and deriving insights from, multiple places at the same time, the relationships between things. And so also, frequently, when you're designing an application, the structures that you're building with have relationships, Maybe a business unit will have products inside of it. A customer will have locations associated with them. Yet there's metadata associated at each of those levels of the hierarchy, right? So I have customer ID maybe, but then I have their name, I have their address, I have a lot of information. But I might also have separately the products that they ordered, and I don't want to always carry around all of the details about a customer when I'm looking at my orders information. So what I might do is I might just store the ID. I might say customer ID 42, ordered product 123. And why do databases do that? They do that to save space, but they also do it to make it easier to change. If I want to change my customer's last name, maybe they got married, right? Then, I only have to change it in one place. I don't have to go back through my orders table and change all the last name of the person whose name changed, right? I change it in my customers table where there's one row for that one customer. Likewise for address, right? Maybe they moved. Very common. It allows us to very, very precise where we update. So very frequently, if you're accessing a database that someone else has put together, things will not be all in one table. It'll be separated out for a lot of really good reasons. And likewise, in our own work, very much, frequently makes sense to keep things separated out by subject area. So we need a way to put that data back together, and so we do that with joins. Joins are horizontal combinations of tables. It's taking a table and it's matching row by row with another table. So here we have two tables we've been working with. We've got ducks and we've got birds. And birds are all birds and ducks are a small subset of a different data set. And what we need to find is a way to match them up. There are ways to do this without matching it. So let's say, for example, we've got birds and ducks. I'll show you an anti-pattern real quick. So we will save this for later. The default, well, you could do something like a cross join. A cross join is going to say for every bird, I want you to combine it with every duck. It's a multiplication. I now have 12 million rows of data. That's it's a Cartesian product, a Cartesian join. Sometimes that's really useful, right? If I have a list of dates and a list of products, and I want to avoid that problem with missing dates, sometimes it's useful to take every date by every product and multiply it. So sometimes you use a cross join. But in general, that's not really what I want. I kind of want the birds of a certain name to match the ducks of a certain name, because I want to add some additional detail that I only have in my ducks table. So I have a couple columns in my ducks table that are unique. That's more data that I have about ducks. So how would I actually combine that together in a more logical way? I'm going to do what's called an inner join. And this is the default in SQL. So if someone writes a query and they just say join, that means inner join. We've just dropped the word inner. And we have to specify how they combine and what we want to join them on. What is the criteria that we want to match them on? And that on statement has a column here from the birds table and a column from the ducks table. And we've added a few other concepts here as well. Previously, we were just referring to columns directly. We would just say species column name. Now we're saying birds dot species column name. It's much like, dots in JavaScript as you refer to nested objects. It's like a key lookup in Python, but you do that with brackets. In this case, we're doing it with dot notation, like you would with an object in a method. But in this case, it's a table and a column, and I'm just getting more specific to tell you where is species common name coming from. Question?
My birds and ducks tables needed a SQL training in front of them.
All right, I can help with that. So it might be that you, in this drop down here, you could choose SQL training, and you might no longer need it. The other thing is you can do that as well. So you can do SQL training. Dot. So that is a three-level reference. Database name, dot table in this case, or database dot table dot column if you want. There's another one called schema, which is a grouping of tables, so you can technically go four levels deep, but in general, you don't have to do that very often. Does that help?
Yeah, no, I got it.
All right, on it.
Let me
Thank
add
you.
one more thing on that, Alex,
Please.
which is there's a SQL keyword that you can use to switch between databases that's called use. So some of you may have experienced that before with other databases that have multiple kind of databases inside the same instance. So that does the same thing as selecting it from the dropdown.
Is this the same as a VLOOKUP?
We will get to that. It's very similar, but it's a lot like a VLOOKUP. So I'll cover the exact differences. So great question. So analogies as we're thinking about an inner join, how similar is it to an Excel VLOOKUP? In this case, an inner join only shows cases where we actually find a match. Whereas a VLOOKUP will have that # NA if it doesn't find a match. So we'll see another case where you just change the keyword to a left join, and it'll be a lot more like a VLOOKUP. So think of this as a VLOOKUP where if things are missing, they disappear. And if you think, wow, that sounds really difficult to interpret, yes, that's why, even though this is the default where it says join, it automatically does this. My advice to you is to use the very next step, which we'll see is to always use left join when you're experimenting, and only when you are certain that they all match, then to use the inner join for that reason. There's one other key difference, and that is that because SQL is working with sets, if there are duplicate matches, you will end up with multiple rows. So let's say my ducks table had a mistake, and I had 2 ducks named Mallard, because they're everywhere. If I join on them, and I join where Mallard equals Mallard, my result set is going to have 2 rows, because I have a duplicate there. Whereas with the VLOOKUP, there's no way to add a new cell into Excel. It only finds the first match, if there was a match. It doesn't return both rows because there's no way in a spreadsheet to automatically kind of add that. So that's the 2 gotchas with an inner join. If there are no matches, they don't come back in your results. And if there are duplicates, you'll get extra rows. So that's a very good question. You had a question as well?
Yeah, I just wondered, if I had like something that very famous type of character name and just like different, is there a way to say like, are these like similar names, or does it have to be exact?
That's a great question. Databases are very exact. They're going to have to match exactly. And you know, I tend to be a self-professed data cowboy. It's the only way that I'm a cowboy like at all, okay? Like just no skills in any other cowboy way. But I like things to be pretty flexible with data. So there are ways you can get very creative. I'll talk about that in a moment, but in general, the best way to think about it right now is an exact match. Jacob.
I was just going to add, you can think about SQL as just like a big math engine. So all it's doing behind the scenes is adding and subtracting, right? And so, you know, if it equals 1, then it's true, and if it equals 0, then it's not. And so that's really how these joins work. There are lots of tricks around that using sounds-like functions, for example, which is very common in Postgres. DuckDB has a lot of functions that can do very, very similar joins, but it is, you know, a fairly complex topic that we could probably spend a whole other workshop on. So, yeah.
Yes, excellent question. All right, so that is the inner join. I wanted to show you the left join, and then I actually have a couple of GIFs that really clarified it to me a little bit. So we do also have some of these descriptions in here about what's happening, and we also have these gotchas, which we specifically talked about, where we only show matches, and we can show duplicates. So something that I am always doing with my joins is I'm always checking my row counts. When I join two things, does it have the amount of rows I expect? Or does it have slightly less than my previous step? Okay, slightly less, change that to a left join, figure out what's wrong. So we're going to do that next. I guess I'll talk about it and then we'll go back to the exercises. So a left join will keep all rows in your left table, and it will only add in the matches that it finds. So we did that inner join, we got 600 rows back because we only have a couple of ducks. There's just not that many ducks. But if I do a left join, it's going to get mad that I don't have my dropdown selected. And I'm going to run it again. And in this case, it's going to return 90,000. That is the exact number of rows in the birds table because there aren't any duplicates in the ducks table. So we checked that ahead of time. So this is matching the exact number of rows in birds, and it's optionally, much like a VLOOKUP, only matching ducks when they exist. So in this case, the column that we're pulling from ducks is author. You can see here these authors are missing. It means that it did not find a match. This is not a duck. It's a goose. It's an eagle. It's something else. But in the cases where we do see a match, somewhere, perhaps, there's only 100 of them, so this is a real trial by fire here. We will see that it's populated. So what I can do is do an order by. So I'll order by author, but then what you'll probably see, there we go. So these are the matches, these are the ducks. So I tend to default to left join to start with. And then I'll use an inner join once I know for sure, because it makes it a little bit faster for the database. And it also communicates my intent to my future reader of, I guarantee there are matches here. You can trust this join. I'm going to call it an inner join. So questions there?
I'm going to add one thing here that Alex just briefly hit on that is a very important point as it relates to interacting with SQL, which is the best way to make your SQL queries faster is to include less data, and that includes columns as well as rows, right? So you'll notice in the join he was doing previously, he was showing only selecting a few columns. That's going to be a very fast operation to do. If you use select star in kind of a naive way, you may accidentally kind of cause your queries to be slow. So it's something to just keep in mind as you think about how this stuff works together.
And I wanted to at least put this up here. If you just search SQL join GIFs, you'll find these. They've got them for both the inner join and the left join and a couple others. And it actually will show you what the database is doing behind the scenes. It's looping through one set of keys, and it's doing a lookup on all the others. Now, this would be the most naive way to go about it, right? To do 2 for loops, where that might take a while. what the database usually is doing a hash lookup. It's going to create a dictionary out of one side, create a dictionary out of the other, and then it's only going to do a dictionary on one side, and it's going to do a lookup from that dictionary from the other side. So it's much more efficient than this, but this is logically the way to think about it. So there are other types of joins. There are, I mentioned left join. Technically, the full version of that is left outer join. So when you think of an outer join, it means I'm including more. I'm including those missing values. So that left outer join is a bigger, more inclusive join. There are also right joins. Don't use them. They add no value. You just change the order. So what's the difference between a left join and a right join? The difference between a left join and a right join is the order of where the tables appear. So in this case, it's not actually left and right, it's top and bottom. Again, it's a little bit gnarly. But birds is our left-hand table here because it came first. Our right-hand table is ducks because it came after. If I wanted to convert this to a right join, I would have to reorder them and then write right join instead of left join. However, it adds no value. And if you see it, fix it because that person shouldn't have done it. And that's all you need to know. So sometimes it'll be auto-generated. This is another one of those cases where, like, when the machines generate the code, it can get pretty ugly. So there's a lot of descriptions of joins that use Venn diagrams. They show all these 15 different types of joins. Inner joins, left joins will get you pretty far. And I'll show you one other thing as well that's important. So we talked about inner join gotchas. Let's talk about left join gotchas. So here we saw 90,000 rows. Now, there are cases where I can, intentionally or not, reduce these rows as well. And that would be in my where clause, where I could do some filtering. But you might have to be a little bit careful. If I want to refer to something in the ducks table, in my where clause, suddenly anything that's missing is not going to show up. I'm going to use another thing that we didn't talk about, using a like operation, which gets to kind of your fuzzy matching there. So I cheated a little bit. I used I, which is a case insensitive like. It says find all the authors that start with A. Now, this returns a whole lot less rows, and it only returns cases where the author exists, which is basically turning my left join into an inner join because I'm using the author in my filtering. So if I care about that column on the other side of my join, that's another case where you'd want to use an inner join, to be very clear. Because the left join, it's not adding any value anymore because I'm being explicit about which authors I want to see. So that's a gotcha on left joins. You can create an inner join out of a left join. How do I mean? What if I said where the author is not null? So this is much like Python. Nothing equals null. So we use that is keyword, just like with Python none. We say where something is none or is not none. Same in SQL. And so where author is not none, I only have 600 rows. Same as my inner join. I just turned my left join into an inner join. And that's exactly what an inner join is doing. It's just a little faster. But you can do it either way, whatever makes more sense. So that's kind of the difference between the two. So this is one where I think a little practice is helpful. So we'll get to that very shortly. I want to at least cover the gotchas. So we talked about a left join usually, but not always, will result in the same number of rows as the left table. So we just showed a case where that was not true because I changed something in my where clause. We also have to be aware of duplicates. Duplicates also still apply in your left join. So that's another case where the VLOOKUP, XLOOKUP analogy breaks down a little bit. All right. So let's do a couple examples. Let's go back up and let's do a couple inner join examples. So let's run a query that gets the species common name, the beak length, the wing length, and tail length of all birds that are ducks. Now this is an interesting question. Birds that are ducks. How do I know which birds are ducks? They're in two separate tables. Well, I'm going to do an inner join because the inner join is going to act like a filter. I'm only going to return matches. So if I join on ducks, I guarantee that my results are ducks when I use an inner join. So I kind of ruined the punchline of this. But that's one way to think about it, is your joins can be doing some filtering as well. That's part of what you have to watch for. I believe you have one other example as well. Let's run a similar query, but group the ducks by species. Yes, so now we're starting to combine concepts as well. Joins and group bys can live in the same query. So in this case, we want to do a join to filter down to just our ducks, and then we're going to use the same approach we did before to do a group by to get some aggregate calculations only about ducks. So rubber meets the road. We're doing it. Raise your hand for questions. Yeah, I always forget. There's so much. SQL is so big. I am using a black pen. We still have set queries. I think I'm going to go pretty quick. We're going to have to skip the original. Yeah, you're important. No, that's fine.
It's fine. Skip by this. Let's see. I think the subgroups and subgroups is important. Yes, that's fine. Just gets to the possibility.
Do you want me to come around? No, I'm sorry. So it's a question about the UI. When I created this example notebook, I did not choose the right option in the dropdown. So you may see a different database there that's not SQL_training. Unfortunately, you do have to change it each time because I made that mistake for every single cell in this section.
So I could have used SQL training in, but my top left was set to, just by default, query _ history _ local.
That's me.
And then, like, it didn't work. So I had to change it to top right, even though I selected use SQL query.
Does you have a semicolon after use SQL?
Yes. So, this user, it's not even an option here, but that's what it defaults to.
That's okay. Okay. Thank you for trying to work around it, but yeah, the dropdown was, had to change it. Yeah.
So even if you use SQL training, that's it, fix it.
Must be because it didn't exist. All right, excellent questions. Does anyone want a little more time? Question?
Is in error left join iterable? Like, can I put more joins one after the other?
That's an excellent question. The question is, can I do more joins? And the answer is absolutely. So there's two ways that you can do joins in a more advanced way that we didn't talk about. So let me write down this join. We'll use it as an example and talk about two ways to extend it. That's an excellent question. So, yes? Mhm.
Sorry, I interrupted you.
Please.
No, so because it was to follow up in that case, the left join, the left database is always the last that has been created looking above, or?
Excellent question. Yes. Well, let's talk about that as well. How do you know which database is the left if you are doing multiple joins? Excellent question. So let's look at it. So this example is running a query that gets these couple columns of birds that are ducks. So I kind of hinted at it a little bit, but let's build our from statement first. So we want to do from our birds, and then we want to do an inner join, which is the same as just the word join. That's our default. And I want to inner join ducks, and I want to do it on birds.species common name is equal to ducks.name. And that's working. It's returning all of my columns. So we see here that we're able to have different names in the different tables. So we don't have to match exactly the names. We get to tell it exactly which columns need to match. One way of extending this that we didn't talk about is you can have multiple criteria. So let's say I wanted to match on first name of bird and last name of bird. I can say where birds.firstname equals ducks.firstname, birds.last name is equal to ducks.last name. So I can have compound keys. So that's one way we can enhance a join. Here we're using just an individual column to map between them. The next way you can do that is by doing additional joins. So you can do another join. In this case, we would need to name it again and something different. And so we can have a different thank you. Right. So you can do additional joins. It's much more it makes a lot more sense if you use new tables, but I only have 2 tables for our demo here. But usually you could join to a third or fourth or fifth. Unfortunately, my record is 22. You can take as far as you want to take it. I just don't recommend it. How do we tell what our left join is if one of these is a left join, right? And this is something that very much confused me when I read SQL for Dummies, that same chapter on joins 4 daggone times, right? How do I know what's left? Is it this on statement? It's actually not the on statement that tells me the order. I can change the order. Let's make sure how many rows do I have here total. I've got my 90,000, so I'm not dropping any duplicates. What if I were to reverse this? My on statement. I have the same number of rows. That did not change from a left join. Didn't change which table was my left. What matters is the order here. The top to bottom order. From birds, left join ducks. So that means that my left table is birds because it's above. It's an excellent question. In this case, when I join down here, what's the left table in this one? Also birds, even though it's not the immediately above table. It's up here. And I'm not trying to be deliberately confusing, I apologize. Just trying to show you kind of the breadth of what you can see. The reason is you look in the on statement to see what are the 2 things that I'm combining. So what am I combining? And then I check the order of the SQL statement to know what is my left. So that's kind of the 2-step process. Figure out what tables are in the on clause, and then look at your order vertically.
So if in the select statement we had selected a column from ducks first, would that be the left thing?
Good. Excellent question. Is the order of the columns I'm grabbing in my select statement, does that determine my left join versus not? It actually does not. You can order the columns in your select list however you like. So let's do it. That's a really great question. So in this case, birds is my left table. I can do ducks.author, and then I can do birds. Here's another trick we didn't talk about. You could do dot star. It says grab all of my columns from this table. So that's another common trick, something dot star. So, excellent questions. SQL is an onion. There are many, many layers. Joins are a really good one to spend a little extra time marinating on and doing a little bit of practice. So I think we may have one or two more examples. This one is kind of an advanced one where we're combining all of it together. So let's do that one real quick. And I think we've talked a lot about the differences between left joins, so we can skip our left join example here. Kind of did that one interactively together. So let's do this one where we combine joins and group bys. This is where we're starting to see the power of SQL a little bit. So here I want to do from birds, and I want to do a join on my ducks. In this case, I only care about ducks. What type of join do I want to use if I only care about ducks? Inner or left? Inner, because I only want the matches. Because that tells me if it matched to the name, I know it's a duck. If it walks like a duck, if it quacks like a duck, etc. Sorry, everyone. Sorry. So sorry. All right, so we've got enjoy ducks. And then I've got my on statement where I want to specify how we join it. So once again, we're going to do birds dot my species name and set that equal to my ducks dot name. So also didn't mention another way you can expand joins. This got to your fuzzy matching question. These are exact equals. Any expression can work. You can say where this is greater than this. I can do where they're like this, where they start with the same letter. Like, it gets pretty far down the weeds. This will get you 99% of the way there, directly matching equals. Yep. So now we want to do a group by together here. So what are the columns that we care about? So we're grouping it by species. So we do want that species common name. And what table is that in? What table? What table does that come from? Birds or ducks? Birds. Comes from birds. I didn't type birds dot, but it figured it out. SQL will figure it out for you. However, 6 months from now, me is not going to have this figured out, right? I can't read that query and say, where did it come from? It is implicit, not explicit. I highly recommend, whenever you're doing something with more than one table, always do alias dot. Okay? Your future self will be so excited. Yes, yes, yes. So great. Okay, so we're just going to do one example of metric. We'll do average beak length. Average beak. And now we're starting to get an error message that says, hey, you need this to be in your group by clause, or you need to wrap it in an aggregate function. So we need to add our group by clause. What are we going to add to group by? What column? Birds.species column, common name. That's the one that's not wrapped in an aggregate function. You'll also notice I broke my own rule. I didn't do birds dot over there. So now we have combined our join. We brought in some extra information. We've got our duck author. We now know what ducks are. And then we can do a group by aggregation to get some metrics about them so we can combine them. Question? The question is the like operation consistent across databases? And that one luckily is. Like is built into the specification and is very consistent. So that one you can trust. It's a very good question. I've instilled the proper level of doubt in the way you guys are thinking about this, which is you do have to check sometimes. What is the syntax for like? I'll give you the high-level version, then we can meet during one of the breaks. But like is you put a string, and then you have wildcards in that string. So you could say something like a percent, and the percent says as many characters or 0 that follow it. So this is starts with a, is like a percent. We can say has an a in it if we put percent on either side of it. That'll get you 95% of the way. You can do a single character with an underscore, so that says the second letter was A, is what this says. It's similar to regex, but not the same. You can use regex as well if you'd like. There are regex functions in DuckDB and most SQL databases.
You want to talk about highlight versus like?
Sure. There's also, by default, capitalization might be a little different between databases, and some databases have a setting where you can say, I want to be case sensitive or not. So you can be very explicit, and you can say I like, which says insensitive like, and you can look in a case insensitive way as well. All right, that was the like in a minute. If you have more questions about like, we can spend more time during a break, but that's a very good question. So, let's see, time-wise. Let's do subqueries and then break. Sweet. All right, so now what we've done so far, we've always been writing one query at a time. What we just did is take data from two tables and combine it back to get one result. Now what we want to do is make SQL a bit more composable. Let's say I want to do some intermediate steps, so that way I can do things in a little bit more logical fashion instead of all at once. So we're going to do that with two methods, subqueries and common table expressions. And we're going to do the classic learning calculus thing. We're going to show you the trapezoid method that no one uses first, and then we're going to show you the right way right after that. So hang in there. So subquery to me is kind of the trapezoid method, right? Which is the way you can do it, but I don't always recommend it. So you can think of it as like a nested query. So anywhere that you have a table, we're selecting from birds, instead of from a table, you can say from this query result. It will give you a result as a table, not persisted, on the fly, just a temporary, ephemeral, table-shaped result, and you can then query that again and do a subsequent calculation on it. So for example, there's different types of subqueries. It can return a whole table, is the most common. It can also return an individual value. So you could say something like, give me the max of this table, and say, I only want data that's newer than that max date in another table. So you can also combine tables this way. It also can return a column. Say, I want everything with a name in this result as well, in this subquery. So there's single value, column of values, or table of values subqueries. And that just depends on kind of where they are in the query. There's not a specific syntax to indicate one or the other. So here we're going to do a scalar subquery. Our subquery is just going to return one value to us. So in this case, our question is, let's find all the ducks with the largest beak length. So, we're going to find all ducks that are above the 99th percentile. We want to find the exceptional ducks, the ones with the biggest beaks. So first, we would be writing a query that would just do that. So I'm going to comment out everything around this query, and I'm just going to run this inner query, and we're going to see what this looks like. So I'm running the subquery by itself. It is giving me a one row, one value answer. So this is what a scalar subquery. It says, look across all the birds that are ducks, because I did an inner join, and give me the 99th percentile. So 72 millimeters, so okay, we're back to pelicans, okay? We're looking at all the pelicans. Now that we are looking at all the pelicans, this doesn't really tell me anything about them. I want to see all of the details about those ducks that have these big beaks. And that's where we use this as a subquery. So we use it as a filter in our where clause. And we say, I want to filter where my beak is bigger than 99th percentile. So I want to look only at the big beak birds. So that's what we have. We just have a handful of birds, handful of ducks, because we did the inner join, that have really big beaks. So we're not pelicans at all, we're ducks. So that is a scalar subquery, because this subquery is giving you back one cell as an answer.
Does this work with SQL?
Probably. Yeah. Oh, yes.
Okay, so I'm going to talk about something just really quickly here that you may have noticed that Alex just did, but something we've put into Instant SQL that is very helpful for these type of things. So you'll notice Alex commented out a bunch of code so that we could see what was inside that where clause. That is the classic way that you debug SQL. So for some of you who have never had the pleasure of doing that, you get that soon. what we have built in Instant SQL is the ability to kind of transparently click into and understand what's happening inside of your of each section of your query. And so if Alex moves his mouse into the subquery, you'll actually be able to see the results that come back in that subquery. And that's just important because otherwise you're constantly commenting things in and out. And so that is a feature that we've added here into the DuckDB UI. It is free, as in you can install it, you can use it wherever you want. And I just want to call that out because it is a very nice feature for being able to understand what the heck is happening in these very complex calculations, because what Alex is showing here is just the tip of the iceberg, and these get very, very hard to debug very, very quickly. So I want to show you that as something that just you can do in this UI that is very, very powerful.
I told you it's my favorite UI. This is why. This alone just saved my bacon so many times, because these are everywhere. These are everywhere. Now, one thing to keep in mind, Instant SQL is doing a sampling. You'll see this number here is a little different than the final answer number. So it's going to show you the shape of data, help you understand how it's calculated, but it's only going to grab a couple thousand rows to do that. So that's one thing to watch. But I can just jump back and forth without commenting and uncommenting, and I can tell what's going on, and it's a beautiful thing. Thank you, Jacob. All right, so that is a scalar subquery. So we're going to skip the example of that, and we're going to move on to, I think, a little bit more common types of subqueries using a with statement. So now we're going to go to the table style subqueries. So in this case, this is an alternative to a subquery. So we saw the kind of position of where that was located was inside the query, kind of in the middle. You can think of it kind of like order of operations. It's going to execute first because it's innermost. But that can be really kind of a pain to go inner, and you can go very, very deep down this rabbit hole. So an alternative is to use this with clause and to just linearly describe these kind of in order and kind of give them variable names. So you're kind of naming your subqueries. So what we're doing here is we're saying, hey, let's name this subquery my duck beaks data. So I use this with clause, and I say with this common table expression, we call them CTEs because that is a mouthful. So with this CTE, I want to name it duck beaks, and I want to see this result. So I'm going to maximize this so that it's a little easier with the screen resolution. And I'm going to run this. I'm going to put it in Instant SQL mode. So we'll be able to see this. So I will click into this first CTE. And so this is the shape of that. It's just give me the ID number, tell me the species, and show me the beak length of my inner-joined ducks. So now I have this CTE. Now what I'm doing here is I wrapped it in parentheses, and I'm doing a comma, because I'm going to do another one. This case, I'm doing the 99th percentile. But I'm not pulling from birds. I'm not pulling from ducks. I'm pulling from what I just named right up above. I'm pulling from duck beaks. I was able to break this calculation into steps. Instead of doing it all in one query or nesting it very, very deeply, I can compartmentalize this. I can do it one step at a time. And this is much like how in pandas, you would set my variable is equal to this one operation. Move on to the next step. Variable equals this next operation that you kind of chain it together. This is the way to do that in SQL. Typically, the drawback has been a lot of uncommenting and commenting to run each step individually. But not anymore. We can click into each one. So this really addresses a critique of SQL that it's very hard to debug. So here I can click into this, and I can see, okay, this is my 99th percentile of just my ducks, because I did this inner join already in duck beaks. Now, these two CTEs by themselves don't actually run anything. They're just kind of like saved kind of formulas of how to calculate something. But I need to actually run them with a select statement at the bottom. And so this uses those pieces. It says, grab my duck beaks, do a join, and here I'm doing this greater than join. And I'm saying, hey, I only want to see ducks with greater than a 99th percentile beak, and I just get back those 8 or so ducks. So that allows me to break things apart. Question? an excellent question. The question is, what's the advantage of using a with statement instead of saving it as a separate table? Excellent question. When I first started, the main reason to use withs is because I didn't have access to make new tables on my database, and I was restricted. So that's one advantage. This is not being persisted. It's done on the fly, which means that maybe my BI tool would write this for me, and it doesn't have to get saved back to the database. I could write it without permission, so that's one. The second thing is it's isolated, right? I can change it, and nothing else will change outside this result. It's my own private thing. I'm just working on it myself. The next is that it doesn't have to go persist all that data back. Frequently in a database, the slowest operation is working with the network and working with disk. And so if you have to save a whole copy of your data set, if your data set's a terabyte, that gets out of hand pretty quickly. So this allows you to do the calculations on the fly. You do have a few other design options. So you listed 2 great options. Make a separate table for each processing step. That can be a great pattern in many cases, because then you can go look back and see what was the value in that table 2 days from now and see what it was. So that's a great option. CTEs are another option. It's local to my exact query. Jacob mentioned another one earlier. It's in the middle. It's called a view. A view is done by doing a create view statement, and it is identical to a CTE in that it's kind of a recipe. But it doesn't persist the data. It doesn't actually execute until you go query that view. And you query a view just like querying a table. Select star from bird's view. And it acts just like a table and gives you the answer back. There is no way to tell if something is a table or a view just by looking at a SQL statement. That's fun. So what you'll see in a lot of old databases is every view is named v underscore the name of the view, because inspection tools were not great back in the day. For us, you'll see it in the left-hand panel. You'll have a different icon for view versus table, so you can easily see it while you're in your IDE. And some of the metadata functions where you can say, like, show me all the tables in my database. The views won't be there. There's another one for show me all the views, and you can look there. So to recap, everything can be a table if you want. You can create a view, which is reusable by multiple people, everyone using your database, or you can use the CTE, which is totally local to this one result.
I just want to add one thing. In the context of this, that was a really good question about like when to use tables versus views versus CTEs. And for those of you working on particularly large data sets, especially in OLTP databases that are transactional, you will definitely notice that CTEs do not play very nicely with your query planner. So it is something to keep in mind, especially using Postgres or SQL Server or Oracle. Oracle maybe not so much actually, but for those of you that are using kind of those types of databases, you will often see performance really matters for materializing these, for example, as temp tables. So something to keep in mind in analytical style databases, Snowflake, Databricks, DuckDB, et cetera, use as many CTEs as you want. They're not going to impact the speed of your query.
Yes. The older database you're using, the less likely you want to use a CTE. Yes. Oracle is, the oldest. IBM DB2 may be a little older. So if you're using one of those two, first, I'm sorry. But second, yes. Okay. All right. I think we'll give one exercise, and we will take a break. Wait, we want to do an install as well.
Yeah.
Okay.
Why don't we take a break just on this? We'll skip the exercising.
Okay, great. All right, so what we want to do, we will skip those exercises. They're left for the readers, which means if you have extra time during the break, take a look, try it out, ask us questions. What we will do instead is we will get you set up for the next section. So the next step is to configure a code space. So let's see, where did we have the install instructions? All right, sweet, so it's right here. So if you go to motherduck.com/SciPy, that'll take you to our, this exact page? Yep. Okay, great. Head over to section 3, and you're going to go to the GitHub repo that is there, and you will go ahead and add a code space. So I'm going to do that for us real quick.
You do need to be logged into GitHub to do this.
All right. So I'm here at GitHub, and in this big drop-down where usually I'm just, stealing my, I'm just, cloning the repo. Instead, go over to this tab that's Code Spaces. And instead of just immediately creating a code space, to make it go a little faster, click on the ... and do a New with Options. And what you want to do is create additional cores. So your machine type, instead, do at least 4 cores, get some power. So that's the only thing you need to change. And then you'll hit create code space. That's going to take 1 to 2 minutes to kind of set up an entire Docker image for you in the cloud for free on GitHub. And we are going to use that to do some Python and SQL combining. So you'll click that. It will get it set up. You'll get a VS Code style interface right in the browser. And once it's set up, we can also show you you can use a desktop version of VS Code as well. Either way. Anything else you'd add?
No, let's come back in 10 minutes.
Yep, come back in 10 minutes. And that is 11:17.
Okay.
I didn't leave you a ton of time.
That's okay. That's okay. We'll do some stuff.
I think we'll skip first one on this. What about the marketing stuff?
We'll just do that here. Something other than just.
What?
I'm gonna keep going.
Okay, yeah, sure.
We won't do it yet, though. Maybe yeah, we'll wait a second.
We're good. This is important. We have to do all that other stuff first. Yeah, I don't have it. I don't know how I'm going to do this. We can do this. I will use my phone. No, I just need to know what I'm going to type. Because I don't have this in the notebook. No, I'll just launch it. Turn my phone on. Don't turn the display off. Maybe I should.
Yeah, go ahead. We'll spend just a little time on this.
Would you study tech? Oh, my wife's a chemist. Yeah, she graduated together in 2014. With 5 years ago, the intern. So she's got. She's good. She works at the local. How are you? How are you? What do you use chemistry? Yeah. Oh, sweet. What do you do? Were you in Cincinnati in the kind of Mecca? I was at GE for a couple semesters, so there was like some volleyball games back and forth. Oh, great. What brings you back? Oh, amazing. Oh, who's that? Steve Burns. That's why we're doing it before the break. Yep. Yes, what's happening?
So she gave me a little bit of colors of instructions, but she's not speaking in the voice. Yeah, it does take like 3 or 4 minutes.
Sure.
Okay.
That's
But the one you have is totally fine. You can use the one. The 2 core one is just.
Does that
Wait, what?
automatically?
had skipped a step. Oh, I think you have to, I think the instructions might be incorrect. I think you might have to hit the 3 dots. That's okay. Now you have 2. But either of those will work. The 3 dots are not, or the 441 is not required. The word totally fine on yours. Yes, yeah, you can go scroll down slightly. I think they might need to build first once they're built. Once they're done building, there's some. It might take, it takes a little bit. The 441 builds faster, I think, because Microsoft needs them on like slightly faster machines. So the 241 builds. You can pop on it and I'll show you what's happening inside. If you click on it. Yeah, it's building, so VS Code is, totally runs in the browser, so it's a good building code space, you see what the Docker images. Yes.
So I was trying to grab the token, which is this.
Yes, that's right. Good job now. So close that. Looks like you have enough down. Just hit the X on that tab. You might be able to cheat here. You just in your code space, just command click on the URL. You should just you can command click. It should go back. It should. So try one more time. I was also seeing this behavior where sometimes it was asking me the token and sometimes it was not. There you go. Nice week. Okay.
Okay, we're going to get started here. So hopefully you have a code space built at this point. And the idea here, everything that we're showing you here, you can also run locally. The reason we're using a code space is just to control the environment a little bit more since we are running a notebook. So it can be a little bit hairy, but if you already are familiar with UV, you probably could run this locally very trivially. UV is a package manager like pip or conda. It's built in Rust, it's very fast. So I'm just going to show you what this looks like to start. And what we're going to talk about now is how we use SQL and Python together. So let me grab my notes here. Okay, so I'm going to run UV init, and so that is going to get everything that's needed into this image so I can run it. The main thing that I care about is actually this Python version file that gets created, and so it's telling me what Python version to use when I run UV. So, okay, there we go. We're going to just simply add the package we care about right now, like this. And so that is going to get everything installed and running on my code space. And now I just do UV run marimo edit, and my server will start, which is like a Jupyter Notebook server for those of you who have used Jupyter before. Okay, it's going to ask me for my token, which let me see if I can grab. Let's see if this works. The last time I tried this, it was just opening it without needing my token, so who knows why it's inconsistent, but that's a separate problem. Okay, let me make this slightly larger. So I'm in Marimo. Is everyone in Marimo? They can see this page. Okay. So I'm going to click Create Notebook. And probably have to change my zoom level. Let's see. That seems good. Okay. So this is a Python notebook. It is very similar to Jupyter. There's one thing I'm going to show you here, which is user settings. For those of you that really care about this thing, where is it? The cell output in this notebook by default is above, and if you want to put it below, just change it here in your settings. I kind of actually prefer below also, so I'm doing that as well. There we go. Okay, so we can just use normal kind of DuckDB inside here, right? And so we can do this. Well, the first thing we need to do is add it to our dependency list. So we can do that by clicking here, not dependencies, packages. And because we were running this inside our UV package manager, Marimo has a nice integration with it. We can just add the packages we want. So I can just do, let's do DuckDB, pandas, polars, pyarrow, and add them. And so if I go back to my terminal, you can actually see here it's doing this behind the scenes for me, adding these to my environment. And then I can go, go back to my notebook. And you'll see that these got added to my packages. So that's really awesome. So we have some data that we're going to grab. I'm just going to pop over to here and just run these. So I'm going to grab this and throw it into my terminal over here. Yes, you can allow. Okay, so I just threw some files here just in the repo, just so we have them for our exercise here. We'll come back to that later. So we kind of have our notebook. Whoops, we have our notebook. We have in the download the files. This is the terminal inside of VS Code. This just puts our CSV files in the top level directory so that we can interact with them. We actually don't need to do this. We can do something totally different, but that's a separate. Yeah, just create a new terminal, throw it in there since we're running Marimo in our other terminal. Exactly right. So now we can use DuckDB inside of Python just like we're using it any other Python library. So I'm going to do import DuckDB, right? And then I can do something like duckdb.execute, if I can spell right. And I can do, I don't know, select 42 as hello world. Hello. Okay, and then I can hit Command Enter to run it or click to run it. That didn't work. Did it not render it? duckdb.execute. Let me see something. Oh, dot fetch all. Okay, I'm missing an operator. Dot fetch all. That is my own fault. Okay, so now I can see what returns from this query, right? And it's nicely nested, and I can kind of see what it looks like here in my notebook. So we can also use SQL interactions natively in Marimo. So you can see that it has this SQL button right here. I'm going to click this. You notice it's going to import Marimo because Marimo has its own little wrapper for SQL. And I can just do, what do I want to do? Select 42. We'll do the same query. We'll do 43 so we know it's a different object. Hello world. We'll remove our from. Okay. And so I get an error, right? And in this case, it's telling me, hey, I'm missing a library. And so I'm just going to install it. This is SQLGlot. It's safe to install it. So we'll add that. Great. So it's installed the library, and I will rerun it. And now I can see that I get a nice view on the data that I just selected inside of Marimo here in my notebook. So what if we want to use pandas? I'm sure a lot of you have used pandas or use it daily, or that's kind of your part of the great Python experience with data. So we can use this, but what we want to do is we want to kind of pass objects between pandas and DuckDB. So how do we do that? I'm going to show you. So we're going to import pandas, and we're going to just create like a let's see. We'll just do the PD read CSV, right? Read and we'll just do ducks.csv. And so we've created a data frame here, right? And I can do, oh, yes, as PD, thank you. Okay, so we have a data frame. And then we can do, I can never remember the syntax here, but what am I? Let's just give this a better name. Ducks, pandas. There we go. Pandas. What is it? Is it head? I can never remember. PD.head? No. Whatever. Okay, thank you. Okay, so now we can see, obviously it's reading the file correctly and it's rendering it for us here, right? Well, how can we use, what about SQL? Can we just use SQL with the pandas data frame? The answer is yes. So we've already imported DuckDB previously. So now we can do just DuckDB SQL, and we'll just do select star from, and we can actually use the name of the pandas data frame. And we'll just do fetch all, just like we did, okay? And so it's going to return this data set as a DuckDB box. It doesn't render very nicely, honestly. But so what we've done here is we've actually passed in memory using arrow from pandas into DuckDB, right? So what this means is you can interchangeably move objects without deserializing them into pandas or SQL and move them between these different runtimes. So of course we can also do this. If I want to return it back as a data frame, I can just do this. So now I've taken it, so I did a fetch all, which is executing SQL, and instead it's executing it back as a data frame and returning it back into my, my notebook environment here, right? So that is really, really neat. Obviously, pandas is really great at reading CSVs, right? A lot of you have probably used it for that in the past. And so a common question is like, when should I use DuckDB versus pandas in reading CSVs? The DuckDB CSV reader is quite good. And if you have messy, gross CSVs that have lots of problems in them, you should use DuckDB. It has a bunch of error trapping, a bunch of nice affordances for you as a user, and it's much more memory efficient. And so what that lets us do is really handle kind of those gross CSV data sets that we all know and love. Yes?
Last year I would have told you to use pandas with your gross CSVs, but DuckDB actually invested a huge amount of time in actually making this the CSV reader that's most likely to actually read your CSV. It can handle the most weird garbage CSVs out there by an actual benchmark, and it actually should be your default way to read a CSV now. I'll be bold enough to say that. No more pandas read CSV. That was the. So we're being bold about it because you can use either, but it's worth a try.
Yeah, and just to Alex's point, if you want to turn that back into a data frame, right? You just use .df. Now I have a data frame, so I can use the DuckDB CSV reader, pass it back into a data frame. We're going to do a quick check-in back here on Marimo. I'm just going to give it a name. I'm just going to call it my notebook. And I'm going to click Save. And why I want to show you this is because now we have a Python file. Yeah, go ahead.
There's a difference between fetch all with the parens and without. So without the parens, you get a nice rendering.
Yeah, I think so, right? Let's see. Yeah, I think oh, yeah, down here, right? Let's look, fetch all. Yeah, so this is basically returning the native DuckDB rendering of it from the command, or from like the Python. And we use fetch all, it passes it back as a nice object with the parentheses to your Marimo notebook. Yeah. No, it's okay. That's great. Okay, so we've saved our notebook. I gave it a name, my notebook. I just want to check in on it in my code space just so we can look at it real quickly. So this is what our notebook looks like kind of behind the scenes here. And why I'm calling this out is because you'll notice this is just a Python script. This means we can source control this Python script, and it means we can run it just as a Python script, right? So it's a little bit different than a Jupyter notebook in kind of in some important ways here, and this is very, very helpful for thinking about reproducibility and how you can use SQL and Python together. Okay, so we can do a little bit of the same type of operations with polars and Prawiroatmodjo if we want. So let's do the same. So we're going to jump down here. Whee! Okay. And I'm going to import polars as PL. And we're going to import Prawiroatmodjo because I think it's necessary for our friends at polars. Okay, so I'm importing some libraries. And then let's do the same thing where we can read a CSV as a polars data frame and then use it again with DuckDB. So let's do the same. So let's do ducks polars equals pl.read CSV. We'll do ducks.csv and we'll just make sure this runs. Okay, good, it does. Doesn't do anything, I think, because polars by default is lazy execution. So let's do this, duckdb.sql. And now let's chain it into something that will just run. Select star from ducks polars dot df, sure. Right, and again, what we've done is we can run SQL against this. Let's just make sure it works, right, I guess. Let's add a predicate where year is less than 1800, sure. Ooh. Okay, so we're getting an error here, right? We got an explicit cast type. Let's just do this, integer H. Fleming. Ooh. Does not like the data that's coming from our data frame. Why does our year column have some? Oh, well, there you go. So we have a problem in the polars CSV parser. Yeah, correct. That's very fun. I think we can exclude it in SQL. Let's see. Where year is not equal to, like this. Okay? And then, year is less than 1800. Okay, so it's still not doing it. So this is actually a really interesting case where you can throw this into, let's just give this a name, df. We'll just call this clean df, right? Whomst among us has not done that before? And now we can do the same thing, right? And do a duckdb.sql select, from clean df where year is less than 1800. I think we've got to cast it to an integer also. Okay, great. So again, what we're doing here is kind of passing forth these in-memory objects using arrow between polars and DuckDB and pandas and whatever you really want to use. And why would you want to do this? I'll just say it again. Maybe you want to use sklearn or XGBoost or some Python machine learning package. It's all available here. You can do your data prep in SQL, do it super fast, and then pass that data frame into whatever library you want, very, very trivially. We have an exercise here, but I do kind of want to get a little bit into some of the AI functions just to take you into what the future of some of this stuff may look like. And I suspect most of you know way more about Python than I do, so it's probably a better choice in use of our time. Does that make sense to everybody? Great. Okay. So let's see here. I'm going back to my VS Code, and I'm going to kick off DuckDB in the UI just like we did before. So I'm going to do DuckDB-UI. And it's going to ask me to open it in my browser, which I can do. It's very cool that this works, by the way. I didn't know that it worked.
This is different. We're launching a from the code space. We'll do that next time, huh?
Yeah, yes, yes. Oh, yeah, sure. I just ran DuckDB-UI from the code space. So we've installed DuckDB in the code space, right, just as part of the Docker build image. And so I can just kick it off from here. And now I have a blank, notebook. Okay, so let me zoom in a little bit. I'm going to click sign into MotherDuck. I'm not going to click sign into MotherDuck. Okay, that path doesn't work. Don't do that. Okay, forget what I just said. Should we just I guess we need to do that locally.
You can either do it locally, or you can just go to motherduck.motherduck.com.
Oh, yeah, we can just do that. That's fine. Okay, so I have a MotherDuck account, so I'm just going to log into my MotherDuck account here. And this should look very familiar to those of you that were just using the DuckDB UI. Part of what MotherDuck is working on is that DuckDB UI that is part of our contribution into the world, and parts of it will be open sourced over time. It's a very, very fun thing to be unified on.
Yep, so feel free to set up a MotherDuck account to follow along. If you go to app.motherduck.com, it's a free trial where you get the full horsepower, so you can use a bunch of cores while we're testing today. And then there's a permanent free tier, so there's no credit card you need to put in or anything. You can just sign up with an email address, and you're off and running.
Okay. So we're going to skip sharing, I think, Alex, and we'll just jump to the AI stuff.
I think that's perfect.
Okay, great. Wow, okay. That's fun. I think I just failed to get a back end.
The UI, did you have anything filled in? I'm just getting blank.
No. I did not have anything filled in. So hang on, it's getting my DuckDB instance. Go! You can do it. Maybe. Okay. That looks like it's working. Yeah, me too. I will show you in a second once I get my session loaded. We should have just been able to pop in and.
I'm back on that localhost page, but I don't know if it's supposed to be.
Yeah, that's the right place to be. Yes, yeah, that's a great place to be. Okay, I'm going to try one more thing. That is bizarre.
If you need any help, just raise your hand.
Okay. I can't get a duckling right now, Alex. Fine? Question mark?
Are you doing staging by any chance?
No, maybe. Let me just double check. We'll do this. Okay, that worked. Very bizarre. All right. Well, I'm in MotherDuck, which is where I was trying to get to. So you'll notice that you should see things slightly differently if you log successfully into your MotherDuck account. I am using a jumbo instance because why not? We have different instance sizes that you can use to kind of run your queries. Jumbo is our largest today. And it will work very similar experience to what we have already in, or what you've done so far. But I want to show a couple of things that I really like that are inside of MotherDuck. So I'm going to create a new notebook. We'll just call this Duck AI. Sure. So there's a bunch of functions that we have. The first one I want to show you is I can do like select star from my table like this. Okay. And so when I do this, it shouldn't work. Probably won't work. Yes, I can. Unless I have something in my table, which maybe I do. Okay, let's stop that. Stop it. Stop it. Yeah. Let's see what database. Oh. Actually, you can go app.motherduck.com or sign in, or you can launch it from the side. Okay, I still don't have a duckling, Alex. Shoot. Do you have one on yours? Can you check? We might need to pivot. I think I borked my account last night. Oops. Yeah. Yours is working? No. Okay. I messed my account up. Okay, I'm going to switch to another account. That's fine. No. Yours is working? Okay. Do you want to switch it in? Okay. I think that might take like 2 minutes.
Okay. Then
Yeah, I think that's the correct diagnosis here. Thank you. Okay, let's make this slightly bigger. Okay, so let's try this again. All right, so I'm going to just do from my table, just ZZZ or something like this, okay? And so why I want to show you this is we get a catalog error, which is good, right? That table doesn't exist. And so what we've built into MotherDuck here is feeding that error message back into an LLM that we've trained, and it's going to suggest something else. And you can see we have a bunch of, Alex, you have a bunch of my tables, which makes sense. So it's suggesting a small db.mytable, so I will accept the suggestion. I can just click here, and it will let me run it. Now, where this is really, really, really helpful is if you're writing complex SQL and you don't remember the syntax for something, and you do it slightly wrong, or you miss a comma, or you miss a parenthesis, it can fix those things on the fly for you, right? And especially for someone coming from Python that might be have better autocomplete and a little bit easier to understand syntax, SQL can be quite verbose, and having these types of affordances are very helpful, right? That's the first thing. The second thing is, let's see if Alex has the Duck database. You have scrolling reversed? What is your problem?
Yeah, that's on
Okay, well, we got a bunch of database in here. Okay, which one? Let's see. Let's see if we got, let's do show databases and see what's in here. We can find one that's like something that we like. Oops. So just show databases. There we go. Okay. We got a bunch of databases attached. It's scrolling. Alex, do you have the look attached here? Do you have the look database attached in here? Let me see. I'm just going to grab it. Actually, where it is, eBird share. We can see that one. Here we go. All right. All right, so I've attached a database called eBird, which is, for those of you that are not into birding, is a Cornell data set that has a bunch of birds in it. So I'm going to choose it.
That's one of the benefits of MotherDuck, right? You have hosted databases you can share with your coworkers.
Yeah.
You can even share it across companies. Back
Yeah.
to you.
Thanks, Alex. Okay, so I don't really know what's in this, so I'm going to do show tables. And it's showing me I've got this snow goose table. So let's do describe snow goose, like this. And we'll get to what we're trying to do in a second. Okay, so it's got some information in here, right? We've described our data. Now, I don't really know much about this table. I can do, summarize, right? For example, like this, and it will tell me information about it. But sometimes I don't, really know what I'm looking for. And in that case, I can use a little bit of prompting using AI in MotherDuck with something that we have built, some functions. Someone was asking about macros and functions earlier. There's some that are built into DuckDB called pragmas, some of which we've augmented. One of them is prompt query. Pramga. There we go. Thank you, Alex. Prompt query. And so I can just give it a natural language test. And I can say, what month has the most snow goose sightings? And that's all I'm saying. And so what this is doing is making a call to the back end, and it's passing, wow, that's a lot of sightings in March. It's passing that query to the back end and returning the result to me, right? Now this is fine and good. That's a great query. But I want to maybe take a look at like what the result is here. Like what query is getting generated here. And so we have another function that's called prompt SQL and is invoked with call for some reason. And I can do the same thing. So I'm just going to scroll the correct way. Okay, and I can run this. This is the same function, and it's going to return a SQL query for me. Instead of running the SQL query, it's going to tell me what it is. So I can just grab it, and we can throw it in here. And speaking of syntax and linting. Okay, so now we can read this. And so it's giving us this information. It's giving me the top row here. So this limit 1 is only returning a single row, right? So it's ordering by total sightings. This actually works fine, but I think I actually want to add year also. So I'm going to just add year. Is that a column? We'll find out. No. But our LLM is smart enough to tell us, hey, do you want to extract year from the observation date? Yes, that is actually what I want to do. Okay. Yes, we need it in the group by. That makes sense, right? So it's saying, hey, change your group by month to group by all. Okay, great. And now we get this information coming together. With a little bit of AI, you don't need to know so much SQL. This is the type of stuff that we're working on making really, really easy with MotherDuck. Yeah, so that's that part. That's all I had for AI. There's one thing I will ask this group. Who here is a Claude user? Do we have any Claude users in here? Okay, so for those of you who are using Claude, there is also a MotherDuck MCP server that you can use to connect to MotherDuck. And you can use it with Cursor or Windsurf or other MCP-compatible AI tools. And that can actually read the schema and write queries against your database for you. It also works with DuckDB. So you don't need to necessarily be a MotherDuck user to take advantage of this, right? The last thing I will call out, just as I guess a quick self-promotion, is we did do a talk at Data Council a couple months ago about what it looks like to vibe code kind of with data science and AI and Python together and SQL. There's a blog post we've written, and I think it is squarely on all the stuff we've been talking about today and how you pull all of these pieces together, right, and use AI in ways that are augmenting the work that you're doing already. So we're definitely thinking about how all of these pieces fit together and how you use it. I'm happy to talk more in detail now, I guess, if anyone has questions about
what it looks like to kind of use these tools with DuckDB, and why we think DuckDB is particularly well suited for using this. I guess I'll start with it. Just a quick why. Why DuckDB and SQL together and with AI? And the answer to that is it's isolated. So for those of you who have used a little bit of AI to generate code, sometimes it likes to do things like drop database. Don't really want to do that typically. You gotta be very careful. If you're running it on DuckDB locally, it's fine, right? Maybe you don't want to be supervising your agent the whole time while you're running something, okay? How do you isolate? How do you do this in a safe way, right? And so with DuckDB and MotherDuck, you can do this in a much, much safer way. My kind of core workflow when I've been doing this has been replicating a subset of MotherDuck data locally to DuckDB and then having my agent answer questions against it, right? And that has been very, very, very helpful. You can do that with MCP. Without it, it all works. There's some very clever things we can do, which we have written about. So happy to take questions about that as a kind of, final, final thing here to keep going. Yeah?
I feel like I should have been applauding a couple minutes ago and seeing you put all that together in one environment. Is there like a link for like a demo like this so I could see an example? I guess I could just report in a couple of months. But
We can definitely put something together for you.
Maybe some gifts and other docs maybe would fix it?
I mean, there's some stuff in Fix It, but I think like it's really about this flow here. Why don't we?
That was a great example of multiple, accept and run.
Yeah, sure, right. Like it in ways that are helpful, right? Like I think sometimes when you're working on these data sets, it can be very, very unhelpful. So we've definitely been trying to make sure we're helpful all the time. We can put together a demo. I don't know. Do we get a list of attendees? Probably not. Right? Yeah. Okay. Let me. Yeah.
A Slack channel as well for the conference, so that might be a spot we can look at that. But
yeah. Let's do that, Alex.
Yeah,
we'll follow up. We'll follow up and drop it in the Slack channel. Yeah.
Are all of these AI prompts and stuff? That's all housed in MotherDuck?
Yeah, so the AI stuff is indeed MotherDuck side. There are extensions for DuckDB that have similar implementations where you could bring your own API key, for example. But yeah, we in terms of implementation on top of SQL using those AI functions, that is indeed part of MotherDuck. Yeah.
Other questions?
Can you explain what the pragma and call are?
Sure.
Is that some part of the AI, or is that Python, or is that SQL, or what is it?
Yeah. So pragma is a is a function borrowed from SQLite that are like system level functions, and we have borrowed those in DuckDB as well, and also implemented in MotherDuck. Why prompt query is a pragma and the prompt SQL is a call? I'm not sure on what the reason is. I think they might be chaining them together behind the scenes.
You can also do call pragma _ prompt query. You want to try that?
Yes.
So call is just like the word execute. It says run this function for me. Is all that's doing. And pragma is saying run this function for me, but it happens to be a function we've kind of considered a system type of function. But you can think of the word pragma as call, functionally similar, or like execute. It's kind of what pragma is doing there for you. But it's based on SQLite.
Is it pragma prompt query?
Well,
I don't think this one works.
Okay,
but
that's on me.
That's okay.
Doing it live.
Yep.
Yeah.
Yeah, their system level functions is the short answer. Yes.
So are those two doing the exact same thing, or are they
So yeah, good question.
things behind the scenes?
So pragma prompt query is generating a query with AI and running it. Call prompt SQL is just generating the query for you, right? And so my workflow generally is use call prompt SQL to generate a query for me and then modify it or inspect it before I run it. Yeah. It's a good question though. Yeah, they're very, very similar. They achieve similar purposes for sure.
Can you do a 1 minute summary about that?
Yeah, you want to do it? Go ahead.
Well, thank you guys. Happy analyzing. Thank you for being here.